Please just let me know if my voice is clear or not. Please, I have to be sure. And, can someone just type it to let me know if my voice, if you can hear me very well? All right, so I will move on then. All right, we have the interval scale and we have the ratio scale. Now you have to understand this data even before you start working on your on any research, because a research without data is almost not interpretable, because data is important for every research. It is with that data you'll be able to make conclusions and recommendations or future study. Is that okay? So I'll move on now. But for the purpose of this class, we'll be looking at biological data. Please, we'll be examining some biological data. So I said here that what is biological data? These are data that it refers to of data derived from biological sources related to organisms such as humans, plants, microorganisms, and ecosystem. And we have different types of data in biology. We have the proteomic data, the psychological data, we have the clinical data. But in this case, we'll be looking at the clinical data in this hands-on training. We'll be looking at clinical data. So what are clinical data? They are data that involve the patient, that involves record of patient health, treatment outcome, disease progression data. So we'll be looking at this particular area of the biological type of data. All right, let's move on. All right, we have common type of biological analysis. We have the descriptive analysis, the inferential, we have regression, we have the survivor, the ANOVA and the t-test, correlation, the cluster, the multivariate, and the bioinformatics. These are the common type of these these are the common types of data, the analysis that we perform in the biological analysis. Please, you have to understand at least, at least, uh, let me just say, for a start, have an understanding about this descriptive and the regression, and maybe the ANOVA and the t-test, because in clinical data, you tend to revolve around all these things. And we'll be doing an example today. So let's look at a particular study. I said, consider the biological research study. The data set is designed to simulate a study on the effect of drug on blood pressure in two groups of patients, treatment group and a control group. I believe I have some biological students here that that can attest with me that whenever a drug is being created, there's always a treatment group and we always have the control group. I think they call the control group the placebo. Am I correct? I think the control group are being called the placebo, right? So whereby before you can test a drug, you have to have two groups whereby you test your drugs on the treatment groups and then a control group. So to know the effects of your treatment. Now, we have this research study here. Now look at the variable in the data set. We have the ID, which is the patient ID. That means the first person, second person, third person, fourth person. Then we have the age of the patient, and the age is in years. Now we have the gender. Gender, we have one for male and two for female. We have the group, I mean the two groups. One is in the treatment group, the other one is the control group. Then we have a variable called pre-BP, which means the blood pressure before treatment. That means during the experiment, their blood pressure was tested and it was recorded in millimeter mercury. Then again, their post-BP was tested. That means that their blood pressure was also recorded after the treatment. Then we examine the weight of the patient in kilograms, and then we examine the cholesterol level. Now, you have this particular study, and you have this particular variable. Your first question is, what are you doing? That's the first question. Because someone can just give you this thing, or you can conduct an experiment and have this variable. Then the question now is, what are you supposed to do here? What are the things you are expected to do here? And that is why it is important that before you conduct any any analysis, or now I'm going to handle this class both as a data analyst and also as a non-data analyst, please. And I'm going to emphasize more on you trying to build yourself in as a data analyst. I mean, not even in biological research alone, even all around. So one thing you have to understand is that whenever you have your data, just 2% of the problem has been solved. The bulk of the work is what are you supposed to do? Because without understanding the objective of the work, you will not know what to do. So you have to go back to the question to design a study that to study the effect, you see, effect of drugs on blood pressure. So the first thing you look at your scale of measurement. You set up your research question. You set up your hypothesis for the research question. You draft out the type of analysis to do. You decide on the choice of software. You analyze, you report, and you interpret. Now, that takes us to the next thing. All right. So um, these are the research questions for the work. And look at the first research question is there a significant difference in the mean post-treatment blood pressure between the treatment and the control group? So these are the research question that was designed for that particular study. And this is what will let me know what exactly I'm supposed to do in the analysis. Now, in 2 minutes, I'm going to emphasize this before we enter the training itself. In 2 minutes. Now, look at the word, take note of this thing I'm going to highlight now. I guess I should be able to highlight here. I want to highlight something. Okay. Look at this word significant difference. Please, if you have a pen, note this down. If you whenever you hear the word significant difference, your thinking should be towards test, test of hypothesis. Whenever you hear the word difference, your thinking should be targeted towards t-test, all those t-tests, one sample, get sample, independent sample. So that means that in this first research question, you have been able to identify that t-test is most suitable. Second one also, it has significant difference. You have been able to understand that whenever you hear the word difference, t-test is meant to be used. Now, the third one also is t-test because we have significant difference here. But now take note. Take note. They said, are there significant difference in this across different age groups? Now let's go and look at it at our data to understand how many age groups we have. All right, hold on, please. All right, let me just continue. All right, then the fourth one says, is there a significant correlation? Correlation. Whenever you hear the word correlation or relationship, let me change it to the word relationship. Whenever you hear the word relationship, then your thinking should be towards correlation. Your thinking should be towards correlation. So that means that these words are very important. Now look at the last one that says impact. Now, whenever you hear the word impact, your thinking should be towards regression. Is that okay? So you'll be thinking of regression in that situation. So all these keywords you are seeing here, they have meaning. They have meaning. So it's you have to understand them first before you can embark with your analysis. Then you design the hypothesis. You have the hypothesis for each of the research questions. So now let us get started. I think someone is messing with my slide, but no problem. So let's get started with the analysis. Now, like I said, your choice of statistical software to use depends on you. Everything you are seeing here in this objective, in this research question, can be done using SPSS and R. Now, this is how R looks like. This is R interface. Please, can someone see my screen? Can you see my screen here? This is how R looks like. R is totally a programming tool. You write code in R. If you can see my screen, just let me know. This is how R looks like. Can someone see my screen? Can someone see my screen? Yes. So this is how R looks like. You can see all the codes here. These are the codes that generate some of this plot you are seeing here. You can see this is a special institution. This is also a biological research that deals with vaccination across the country. So this is how the R looks like. But for today, we'll be focusing on the SPSS in as much as it's a general tool used by every field of study. So this is R, and this is SPSS. Now, I am using SPSS version 22. The latest version right now is version 26. So whenever you want to download the SPSS, you can make use of the higher version depending on how your system can carry it. Now, First thing we have to do is open your SPSS. Now, this is my SPSS. Now, in SPSS, you have two views, the data view and you have the variable view. The data view, now this is data view. From the word data, it simply means that is where your data will be. Now, let me show you the data. This is the data set in Excel format. You can see the patient ID, their age, gender, the group. That is the treatment group and the control group. This is the measurement for the blood pressure before treatment, the measurement for blood pressure after treatment, the weight, and the cholesterol level. So this is my data set, which I want to work with on SPSS. Now, things you have to take note of is that, okay, so I hope I'm not too fast. We just have a lot to cover in just few minutes more. So just bear with me. All right, we have this SPSS interface. And I've explained that we have a data view. Now, you can there are two ways you can push your data set from Excel into SPSS. The first one is you can either copy, let's say we are copying everything, you can either copy Control C, then go to SPSS, go to your data view and paste Control V. See, you can either copy and paste. You have it, the data is already here. But this is not the best way because look at our variable names. It's not showing. It's not like this one where we have ID, age, gender, group. What is here is quite different from what's in the Excel file. It's because you just copied and paste. So you really want to start formatting, and by saying this one to ID in the variable view, this one to I think age. I'm guessing age, right? The second variable is age. Then this one to gender. And if you take note in the Excel file, there's no decimal point. No decimal point here. But in SPSS, it automatically puts decimal point there. So you can go back and reduce decimal point, reduce it. So that will happen for we have done for age, we have done for ID. That's the way you can that's the first way you can import data set into SPSS by copying and paste. But like I said, it's stressful. It's more stressful, especially when you have like 50 variables. But let's assume that you want to import it because you can automatically import your data set. But first thing first, whenever you want to import your data set from Excel into SPSS, you have to ensure that the Excel file is closed. If your Excel file is open, it will not import. Should we try it? Okay, let's try it. So I have my Excel file opened right now. It's opened. And I have SPSS opened. I come to file. I come to open data. So it's going to locate it. I think I kept it in my desktop folder. All right, biological analysis class. And then you see it was blank. The file should be here, but it is currently blank. So why is that? Why is it blank? The reason is because look at the file type that is showing here. Remember that my Excel file is a CSV file because anytime you're working with analysis, the best file format for your data must be in CSV, comma delimited. So, but in this case, I have it as SAV, meaning that it's not saying any Excel file here. So you have to come here, you look for the file extension for your data. For my own is .csv. So I have it here, .csv. You see, it already brought out the Excel file. I open it. So it's loading. You click on next. Then you come here. SPSS asks, are variable names included at the top of your file? Yes, it is included. These are the variable names. They are included. It said that if they are included, and in our case it is yes. You click on next, click on next, click on next, click on next, and click on finish. So what's going on? We should be having our data set shown here. Can you see? But nothing is showing. That was why I said immediately you want to start working on SPSS. The reason why this thing is not showing is because my Excel data is still opened. That's why it was not showing in the SPSS. So let's close it now. I've closed it now. Okay, it's already closed. All right, it's closed. Now let me import again the same way I did earlier. So let me go look for it again. All right, this is it. So I have it here. Next, variable names included on top of your file. Yes. Next, 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 next. Finish. So what will happen? Can you see automatically our data is imported because I have already closed the Excel sheet. So please take note of that. I had this issue when I was learning SPSS too. When I started SPSS, I was lamenting. Why was my data not showing? I now realized that was because of the fact that my Excel sheet was still open. So you have to close it first before the data can import. Now look at, consider this one is more beautiful than the other one because here variable names are attached automatically. The format of the digits is correct, no decimal point. You don't have to start changing anything. So this is the first step of your analysis. And that's why, as a data analyst, you must learn how to charge clients big money because you are not doing something small. Imagine you want to analyze data and you still have to go through all this stress before you start. See, we have not even started the analysis at all. What we have just done so far is just importing data and the like. So please know how you rate yourself in times like that. So now we have our data set shown in the data view. The next thing is for us to have it. Okay, let's look at the variable view. The variable view contains from the word variable view. So it's where your variables are being shown. Your variables will be shown here, and your data will be shown here. All right. Now the next thing is that let's go back to our slide. Check your data over variables in data set. Look at the age variable. Look at the age. What is the measurement? What is the scale of measurement of the age variable? Can someone tell me? Can someone just let me see if maybe one or two answer. What is the scale of measurement from, we have discussed scale of measurement here. We have the we have the nominal, the ordinal, the interval, the ratio. What is the scale of measurement for gender in this case? Anyone? Please quickly, let me just see one answer. Who knows the scale of measurement of age in this case? Is it ordinal? Is it ratio? Is it interval? Is it scale? So if you know it, just type your answer in the comment box. Then we have gender. Look at gender. Gender is that perfect. Someone say, oh no. Someone say interval. Someone said nominal. All right, nominal. All right, I would have loved to hear why saying nominal here, and I would love to hear why it is interval. Anyways, we can discuss that at the end of the training. So we have the age variable, we have the gender variable. So after you have imported your data set into SPSS, the next thing to do is you now start coding. You code your variable. You code your variable. What do you mean by coding? In this case, look at data view. What you have here is just, look at gender. What you have here is just 2211, 2211, 2211. A layman can just open SPSS and be asking you what is 2, what is 1. You don't have to explain too much. All you have to do is come to the variable view, come to gender, you come to values. So now look at our slide here. The slide says 1 is for male and 2 is for female. You come here. That means that whenever you see 1, turn it to a male. You add it. Whenever you see 2, make it female. What we call this one is coding. We call it data coding. So if you come back here, you will see that it has changed to male and female. It has changed back to male and female. So let's change the group variable. For the group variable, you come here also, click on group, click on values. Okay, for the group, we have 1 is for treatment and 2 is for control. 1 is for treatment. 1 is for treatment. Then 2 is for the control. All right, added. So this has been sorted. Do we have another group variable? Okay, we have okay, I think that's all. We only have 2 grouping variable. Now, let's look at the first research question. The first one says, is there a significant difference in the mean post? Oh, before then, there is something you guys know we have to understand that before the start of any analysis, before answering your research question, the first thing you are expected to do is the descriptive statistics. You are expected to carry out the descriptive statistics. That's the first thing you are expected to do before, even before answering any of your research questions. To do that, now look at age. Age is a continuous, is a continuous variable, right? We can carry out statistics for age, BP, weight, and cholesterol because we can perform mean, median, standard deviation on them. So to do that, you come to analyze, you come to descriptive statistics, you come to descriptive. Let me come again. Analyze, descriptive statistics, descriptive. Click on it. Select age, put in a box. Select BP in a box. Select post BP in the box. Select weight in the box. Select cholesterol in the box. You can come to option. Now automatically SPSS has picked mean, minimum. Hold on, please. SPSS has picked the mean, all this one. So you can pick the sum, you can pick the range, you can pick as many as anything. Click OK. Then click OK here. Then your output will be shown here. Sorry. Your output. Hold on. What's going on? Please pardon me. Let me cancel this. All right, let me redo it again. I think there's something went wrong. Click on OK. Hold on. What's going on? The result should be showing somewhere. Okay, now we have the result here now. Okay, so we have the result of analysis now. That means that look at it. Look at the result you have here. Age. Now, after analyzing, you still have a job of interpreting, but that might not be for today. We have performed the statistics. Then after you have done that, you can go and plot some charts. Let's say you want to plot your histogram. To plot, let's say you want to plot the histogram of the age. You want to look at the distribution of the age. You come to graph, legacy dialog. Then you can select histogram here, age, put it here. If you want it to show a normal curve to show the data is normally distributed, click on display normal curve, then click on OK. Automatically you have your oh sorry, I think I stopped sharing. Automatically, this thing is disturbing me. Automatically you have your sorry, the histogram is loading. Just give it some minutes. Automatically, once you have done the histogram for age, the histogram will show automatically. I don't know why it's taking time, but it should not be taking time. But okay, now graph is processing. Now this is the graph, the histogram. And for those of us, I don't know if we have variants here that did HTA 122 or HTA 224. What we were taught normality, that when your bell your curve is having a bell shape. What does that mean? It means it is normally distributed. I believe you know, right? That when when your when your when your SPSS when your histogram is having a bell shape, then it is normally distributed. That is what this one just explained to us. So now let's answer, let's say, two of the research questions that we have here. It says, is there a significant difference in the mean post-treatment blood pressure between treatment and control group? Now, if you don't understand the research question, there's no way you understand what analysis to perform. Remember, I mentioned that because we are talking about significant difference, that means we are doing t-test. But the question is, what type of t-test are we doing? Because we have the paired sample t-test and we have the independent sample t-test. We have what we call the paired sample, which is the when you have two samples from the same population. Is that okay? And you also have the independent sample when you have two samples from different population. Now look at this question. It says in the mean post-treatment blood pressure between the treatment and the control group. In this case, we are making use of the paired sample. Why? Because we want to look at difference between just this particular variable. We want to look at difference between this particular variable. So in that case, we are going to use, uh, sorry, uh, let me come again. In this case, we are using the independent sample, not the paired sample, independent, because the post-treatment blood pressure are gotten from two different entities. One is gotten from the treatment group, another one is gotten from the control group. So it is two different results two different people you are comparing now, not the same people. You are comparing two people from different groups, one from the control group and one from the treatment group. To do that, you come to analyze, you come to compare means, analyze, compare means. You see, we have different options for t-test. In our case, we're looking at the independent t-test. You click on independent sample t-test, and we are concerned with the post blood pressure. Now, that's what we're examining. Set the post blood pressure treatment. So you click on post blood pressure, enter the test variable. Now they were grouped into two, right? Treatment and control. So you come to group the grouping variable, put it here. Then it will ask you to define your group, meaning that what does the first variable mean? What does the second variable mean? So you define it by saying the first group was labeled as 1 and the second group was labeled as 2. Remember in our Excel sheet, okay, I think it's here. It was written here that treatment 1 is labeled as 1, treatment 2 is labeled as 2. Please, if your data set was initially labeled as 1 and 2, and you came to SPSS and put 0 and 1, it will not work. It is the same thing that used to label it in your Excel sheet that must be used to define your group. So you cannot label it as 1 and 2 in Excel, and in SPSS you now call it 0 and 1 or 3 and 4. It will not work. It has to be the same group label that's used from the beginning. So you click on continue, then you click on OK. And then we are going to have our results shown here coming. Okay, someone asked the question that what version of laptop am I using to run the SPSS? Okay, I'm using Core i7 and well, I don't know, maybe that's why it is, but I think this is the first time my SPSS is running slowly on my laptop, and I guess because I'm opening a lot of tabs on my laptop right now. I'm having a very powerful software right now. So I think that's why it is quite slow. All right. So let me continue. Now you have the result for the independent sample test. This is your result. Now, what is very, very important in this result is what we call this significant two-tail. This one I'm circling here on my screen. Significant two-tail. Now look at the first value here, 0.094. Now, there's a particular assumption in statistics, or should I call it a law or a conventional rule that says that if your p-value is less than 0.05, you reject H naught, and if it is greater than 0.05, you do not reject H naught. In this case, our p-value is 0.094, and that means that it is greater than 0.05. What does that mean? That means that we do not reject H naught. Now, what is this H naught talking about? H naught is your hypothesis. Now look at what you have here. What hypothesis says there is no significant difference in the mean post blood pressure between the treatment and the control. As a biological, as a clinical analyst, that you have visitor and you want to make an inference from this, you collected blood pressure from two people. You gave them a drug to use. You wanted to know if the blood pressure has an effect on the treatment group and the control group. You see where the picture is, you can paint the picture, right? You gave them drug and you want to see if the drug you gave them has an effect more on the treatment group or in the control group. You know, many of us have tested this at home, whereby maybe your parents got a drug and then you don't want to use it first, you now give it to your younger brother to use it first. before you start using it. So you want to know if the effect will be more pronounced on your brother before you start. Not that we have done it before. That means all of us are all analysts one time in our life. So you give your brother drugs to use. Okay, after some minutes you study him. Oh, this boy, nothing is happening to you. That means you see you have tested and hypothesis there. The same thing is happening here. You want to determine if effect of that drug on the blood pressure is more pronounced on the treatment group than the control group. That is what you are trying to examine here. But now, our p-value, which is greater than 0.05, showed us that we are to reject H naught. We are to reject H naught, meaning if we reject this one, what are we now accepting? We are accepting that there is a significant difference. Oh, sorry. Let me retrace what I just said. Okay, sorry, I think I should type it out. Let me type it out let me type it out. Sorry. Okay, so if p-value is less than 0.05, reject H naught. Otherwise, do not reject H naught. Meaning that whenever our p-value is less, we are to reject. If it is not less, we do not reject. Now, in our case here, our p-value here is 0.094. So we have 0.094. 0.094 is greater than 0.05, right? In that case, we do not reject H naught. We do not reject H naught, and then we conclude. Now, that means that if we do not reject H naught, what are we saying? We are saying that there is, no significant difference in the mean post BP between treatment and group because our P value was not significant, meaning that whatever drug you are giving the treatment group to have an effect on their blood pressure, it will have the same effect on the control group too, meaning that that drug does not have an influence on either the treatment group or the control group. You can see that it was the t-test we performed that enabled us to get this out. So you as an analyst, as a clinical analyst, now push this information out in your research. Many of us, we were part of the COVID-19 insurgence that happened where we have people in the lab that were testing and testing. These were the things they were using to test to see if these drugs they are trying to push out for the cure of COVID-19 or cure of cancer, or cure of diabetes, whatever, if it will have an effect. So they will test it on the placebo. They will test it on the treatment group. Then they will now test it using the t-test, the independent t-test. So if it has an effect, they will tell you that, okay, oh, we can push this drug out because we have been able to identify that this drug is working efficiently. It, we're able to identify a difference in how the treatment group were before than the control group. So this is just to let you know that biological data is very important when you have an idea of what you want to do. You have your hypothesis set, you have your research question, because this research question will be the one to start pushing you to know what you are going to do. So for the second one, we are going to use a paired sample. For this third one also, we are going to use okay, I think okay, for this third one, we are going to use the ANOVA. I believe probably in subsequent trainings, we have more time to look into each of these analysis method more better. We have discussed the discrete analysis. We have discussed the t-test, but we still have some ANOVA, the correlation, the regression. But I believe that um, uh, in subsequent trainings, which I believe the organizers might want to look into, you can just examine all these important terms which I've made mention on, and understand that SPSS, whatever you do in SPSS, it can be done in R. Whatever you do in SPSS can be done in R. Now let me now reiterate the difference between SPSS and R. Many of you might be thinking, if I can use SPSS, then why should I go for R? Please SPSS is limited to many things, especially for machine learning of a thing. The way I have done this map in R, SPSS cannot do anything like map. SPSS can't do so many things, but there's nothing SPSS can
No,
do that R can never do. R is one of the most powerful analytical tools in currently after Python or whatever
I
we
don't even have
think
money. I
is
realize I
powerful.
actually don't have money.
So what like I
Check
said,
me.
whatever
Check now, I'm
SPSS
very
can
late.
do, whatever
I don't
SPSS can
understand
do,
looking
R
to
can do everything. But not what R can
mm,
do can SPSS. That is just the
forget
disparity
me. Oh.
between them. You can now all these things I've mentioned in the slides,
Me, I've gone to
all these ones I've mentioned here, you can do all of them in SPSS. That's why they call it statistical package for social sciences. It's not just for statistics students. It is a statistical package for social sciences. So, all right, it's a statistical package for social science, meaning that anybody can make use of SPSS in all fields. But R, you have to be quite more advanced in analysis and the like. But I believe that we don't have much time. I will just wrap it up here. Please, before three things are important here is understanding your research question. This is very important. Your research question is very, very important because without this, you won't know what to do next. After the research question, you go to the hypothesis. The hypothesis lets you know the next thing for you to do. After the hypothesis, you draft out your analytics tool. For me, you see, for me here, look at what I did here when I was doing mine. I listed it out: descriptive, graph, t-test, ANOVA, correlation, regression. This is what, and that's why your supervisors will always tell you go and write your methodology first. And even if you are writing your undergraduate project, some lecturers will tell you, some professors will tell you, go and do your analysis first. Because after analysis, that's when you start knowing how to structure your objective or your literature review and the like. So you have to have an insight on your data and things you will do with your data. So that is just what I have for you this evening. And I believe that um no, this is just an hands-on training. It's a training, meaning that you are not expected to learn it all in a day. But I believe that you have learned the basic part of it, which is that before you import your data into SPSS, your Excel file must be closed. You should not open your Excel file. And after importing, you can now start doing your coding all these things. Coding is ensuring that they're in the appropriate format. Then you can always perform your analysis either descriptive or frequency. You can do frequency. Let's say you want to look at the frequency of gender. Put come here and put gender, then it will display the frequency table to let you know how many are males and how many are females. You understand? Look at now, we have 36% are males, 64% are females. So that is what analysis. These are just this is just the basic thing you should learn in data analysis. So on this note, I'm going to stop here. And if you have, I think I'm going to give it to the organizers now to take charge of the class. Thank you.
Wow, thank you very much, sir. That was such an eye-opening session on SPSS. Thank you so much. And although we are doing this on a short duration, I believe this has opened our eyes to what SPSS can do for us as scientific researchers. So thank you once again, sir. So I don't know, although our time is fast spent because we need to proceed to the last section. But I don't know if it is possible to just give us probably an overview of how to go about it. Probably like basics. If you can do that for the next 3 minutes before we start entertaining questions, sir.
Based of what now? Based of what?
Based of what? What is sir?
I think can you come
I think
can you repeat
can
what
you
you just
repeat
said?
what you just said? Okay, so I said if it is possible to just give us an overview of R,
Okay,
like just like basics in the next probably in the next 3 minutes.
3 minutes. Okay,
3 minutes.
all right,
Okay,
no
all
problem.
right, no problem. Yeah, thank you
All
very
right,
much, sir.
so
All right.
this is R, like I've explained. We call it R Studio. We call it R Studio, but because it's a studio, just like you have Visual Studio for Python and everything, this R Studio. So in R you have four views. You have four views in R. You have four views in R. Okay, coming. pardon me. You have 4 views in R. Now, this view is where you write your code. The one here is where you write your code. The one here is where your codes will be executed. Now, for this part, this is where your data frame, whatever you have done, will be stored here, and here you can view your output in this case. Now, R can be used for many things. So in R, let's say we have this blank R file open. You can open a new file by coming to this file, by coming to this plus symbol here, you come here and click on the R script, So you can start writing your codes. Let's say you want to add one plus one. You can add 1 plus 1. When you run it, you see that the output is showing down here as 2. So let's do something like a t-test. So let's say we have 2 variables. Let's say a to be 4, 5, 7, 8, 9, 10. We have this variable a and we have variable v as 2, 4, 6, 8, 9. I think they are complete. Okay, 7. So we have these 2 data sets. We have the A and we have the B. So you want to perform a t-test on them. To do that, all you have to do is just write t.test A, B. So it gives you your response here as 2 sample tests. So you can see that R is much more easier because it's a code and you can always move yourself around codes. But in SPSS is like click and drag, click and drop, click and drop. That's just the main difference. In SPSS, you click, in R, you code. So you can also plot histogram. In R, you can plot histogram by using histogram as A. So you can have your histogram plot here. Your histogram plot will be shown here, like I said. You can plot it here. Then you can also look for the scatter plot of A to show you the scatter plot of. So this is just an overview of R Studio. You write your code here, your output is shown here, and whatever plots or charts you are working with will be shown here. I kind of prefer R Studio more in analysis because it makes it I can always move myself around writing my codes. I can always, just like in SPSS here, this chart here is kind of rigid. You can do little or no little adjustment to this chart here. Although you can do some, but you can do little. But in R, I can always move myself around whatever I'm doing. I can always write my codes. Okay, let me show you one thing here. I have this data set which I want to plot a graph. Now look at this graph. Look at this graph. Look at this particular bar chart in R. I can easily put my bar labels on each of it. I can change the color. I can use different color. Sorry. I can change the color. I can use different colors. So that is just one of the things that R brings to us. So I would advise that if we are let's learn from the simple part, and SPSS seems to be the simple part of data analysis, unlike the R, because R will require you to do a lot of reading, a lot of studying, a lot of movie, not movies, a lot of videos, not movies, sorry, a lot of videos on R, a lot of things. So please just use the best tool that can work for you. All right. Thank you, sir.
Wow, that was so concise and explicit. Thank you very much, sir. Thank you very much for doing us the honor, sir. And I hope that everyone has picked one or two things from the 2 analytical tools that Mr. Emmanuel has put us through, both SPSS and R. So, and I believe that we have something to take home, to take with us to move forward in our research endeavors. So we now know what SPSS and R Studio, just like he said, can do for us in trying to analyze our results before we go on to publish our findings. So thank you very much once again, Mr. Emmanuel. Thank you very much. That was so beautiful and very enlightening. Thank you, Balkis. All right, so at this point, we'll be entertaining questions. So if you have questions, I think we have questions in the chat. All right, Tohib Yusuf, you said you have a question. Now is the right time to ask, please. So if you have questions, you can just You can just signify or drop it in the chat so that we can read it out. Okay, so we have some questions in the chat, sir. The first question says, how can I get the R software? Okay.
All
All
right.
right. How can okay. Carry on,
How
sir.
can I
Thank
get,
you.
yeah, how can I get the R software? Yes, R is very free. It's free. It's free on their website. You know, they changed their name from R to POSIT now. So you can go to online and search for R, or I can make the one I'm using because you have to in R, you have to download the R itself and the R Studio. There are two setups you're going to install before you start making use of the R console and the R Studio. So I can, if Mr. Sheriff would like, I can share my setup with him. So maybe he can make it available to the students after the training. So number two, after plotting my graph, I noticed a difference in the height of the bars. The software writes no significant. How do I deal with that? After plotting my graph, I noticed a difference in the height of the bar. Okay, but it's okay now. Let me explain what we mean by significant. From the word significant, it does not mean that there's no difference. Whenever you see the word significant, it does not mean that it is not there's no difference. It simply means that that difference is too minute enough. It's too minute for us to say there's a difference. There will in the past there will surely be a difference in it. There will surely be, but the word significant simply means that it is not that large enough for us to say this is different from this. Example: if I have 10,000 naira and another person has 9,500 naira, there's a difference of 500, but both of us are still rich. So the difference is there, but it is not significant. That's why you will see in most reports, in most journals, they will put the word statistically significant, meaning that it is significant in our own eyes as a person, but statistically we cannot attribute that difference to being significant. So that is just what you are seeing there. So just interpret it as not statistically significant, because that is what in as much as we have to follow some conventional laws and ethical laws, meaning that you cannot say that and you cannot just use the height of the bars to interpret. Those are the limitation of bar chart too. You cannot just use height of bars to interpret. You have to test it also to check. You have to test using the normal test to check if it's significant. Okay. Now let me. Okay, this one is saying what is a Likert scale, please. All right, let me show you an example of a Likert scale. I will share my screen now. I think I will need to show you for you to see a Likert scale. All right, I think I'm sharing my screen now. Can you? Okay. How to share for you to see how a Likert. Please, can you see my screen? Not sure. I'm not sure my screen has been shared.
Yes, sir. This your screen is still shared.
Okay. All right. So this is an example of a Likert scale data. Look at this questionnaire. You will find some Likert questionnaire mostly in sorry, what's going on? You will find Likert scale questionnaire. Those are okay. I think it's not showing. Those are questions that you always have strongly agree, disagree, not agree. All those strongly agree questions. Whereby they will say how long what is your how long have you or let me just say how what is your perception about drug abuse, and they will now start asking questions. Strongly agree, disagree, blah blah blah. Those are like category whereby you rank your response according to degrees. The highest one will be strongly agree. After then you have agree, then you have the neutral, you have the disagree, then you have the strongly disagree. Those are Likert scale data. All right, the next one is example when using graph PAF. I don't think I understand what that graph PAF means. All right, please, how can I get the SPSS software? Okay, SPSS software is not free. It has to be, you have to pay for it, but there are some cracked version online. We have some cracked version, which I don't have the link to get it, but the one I have is like I think it's 700 MB, and if I can share it, I can also provide the um the um the ID for you to the paid ID, the license for you to use it. So SPS is not free online, but you can always get a cracked version. But I don't know where you can get those cracked version. But if you want to get it from me, which is a very large file. You have to understand that. But I can always provide a license for you. Now, the next one is it possible to import data sets into R? Yes, very, very possible, which I will show you. Let me quickly show you how to import data sets. Now, I want to import data sets from SPS from my file. Please, am I allowed to do that in just few minutes, please? So I can call it my data. Please, am I allowed to do that, please, sir? Just in few
Yes,
minutes.
please carry on, sir. Please carry on.
My data.
My
Then
data,
the
then the
what to do is just write read.csv because your data is a CSV format. File.choose, meaning that you're telling Excel and you are telling how to go and search the file for you. So when you run it, your R will take you to your file manager. Hold on. If you take it to your file manager, it's just hold on for me. Aha. Take it to your file manager. So I can go to desktop, biological data analysis, and I can pick this data here. So now it automatically it has been imported. To view it, you can see it here. View my data. View my data. So this will show you the data set you have imported. Can you see? This is it's showing now. This data set you're having here. So we have the same data set we open in SPSS. You see that in SPSS we still have to start going through step by step, step by step. In R is just one line of code. Just a line of code give us a data set. So you can easily you can see that this now you can import your data set in from into R. All right, is it possible to will Core i3 be able to run R? No, no, no. It will not be able to. Please, Core i3 will not be able to run your R. Even if you go to our website, they will tell you that you should have from Core i5 upward. You have Core all those higher cores because R is a programming tool, and although it will run, but it will be lagging. It will run, but it will be lagging. That is just the difference between having a Core i3 laptop. It will run, but you cannot just say that I will be you cannot just say that I will be doing little analysis. As you move on in life, you tends to do more. You see, as you move on in life, it tends to do more. So if you are someone that just do normal ANOVA t-test in today, in the next 2 or 3 years, you can be doing machine learning. So you see that your use of your R has gotten more advanced. It's that you just get a more advanced a laptop with a higher core for you to run R very well. Okay, is it possible to use? Now, I'm not saying you cannot use um, Core I to replace. I'm only saying that it will run, but it will be lagging because R itself is a powerful tool. Or is it possible to use different methods for the analysis of questionnaire? Yes. Let me show you this one I just recently worked on a project I just worked on for questionnaire data. This is the project. It's on situational. It's on construction companies in Ghana. So this is the code I wrote for the particular project. So I have you can look at the first thing I did was I I think I put the thing there. I did my social demographics calculus. That's the main. Okay, hold on. Let me just show you. Let me run the code so that we can always can see together. That I will not be saying something different. So I've run my library. All right. So please, I will not take more than 3 minutes. Just to show you what your answer to your question. That yes, you can the question says that you can perform different methods. I want to show you the different method you can use to run your R. We have the frequency and percentage. We have the okay now this data set, and then all right we have this, we have this, we have this, we have this. So if you look at it, look at my results. This is where I have the frequency and percentage for the social demographic variables. So you can go on to now start doing the mean we call something the mean item ranking, where you rank your variables according to their level of importance. You rank them according to how important they are. So look at this one. Let me show you section B. So, all right, hold on. Let's table, let's table section B, and right. So look at what we have here. This is just an example of mean item ranking, where we can always rank your variables to see the level of importance. So this one talks about how important some criteria are in construction industry. So you can see here that out of the criteria that were listed, criteria 3 was ranked first, meaning that in that situation, criteria 3 is the one that is most used in that industry. So many more like that. You can perform regression, you can do a lot of things. So another question is, please, I would love you to share the R software and its setup with us. Thank you. All right, I think I will discuss that with the organizers. That's later. Okay, what does this one implies? Okay, it's called an assignment. It's an assignment symbol. You assign it in, yes. I think an answer has been said here. I think it's assigned a variable, yes, unlike Python that use equality sign. Yes, both R and Python are also use equality sign. Take note. I can call me and put, I can put one, I can put equals to 1, 2, 3, 4, 5, and then I can call, it's a free run. I can see the initial assignment variable. The free run, so everything is the same. It works together. It's the same thing. So I think I have one more question left for the last question. All right, I think that's all. Thank you so much. Yes.
Well, thank you very much for those great responses, sir. Really appreciate you, and I strongly believe that everyone is satisfied with the response to their questions. So thank you very much, sir, once again for doing this with us, sir. We really appreciate you, and I must say this has been an enlightening session for everyone, I believe. So thank you very much. So since we have no other questions left, I think this brings us to the end of the second section in this workshop. So thank you very much, Mr. Ayeni Mana, once again. We are so glad to have you in our midst, and we appreciate you for this awesome session, sir.
Yeah, you're welcome.
So I'm going to reach out. I'm going to get back to you concerning the setup for our studio so that we can share with the eligible participants.
Okay. All right.
Yeah, thank you very much.
Yeah.
So I'll be in your DM, sir. Thank you, sir.
Okay, sir. Yeah.
All right. So please, I want us to engage this chat for like in the next 1 minute. So how was the section, guys? How was the section? How was the section? Did you gain anything at all before we proceed to the third and the final session?
Hello.
The workshop? Oh, very enlightening.
It's been very
Musumola, awesome. Oh, Mr. Victor, you're here.
Yeah, it's been very wonderful.
That's great. That's great. Thank you. Thank you very much. Easy to follow. Enlightening, amazing, and well simplified. That's great. All right, amazing. Thank you very much for the positive feedback. All right, so I'm sure that you guys, you are still going to be I'm more amazed. I'm sure of that, because the next and the final session that we're going to be having today, I'm sure it's going to be top notch, just like the other ones that we've had. So for the final section, we are moving on to scientific research writing and publication. So how do we publish our research findings after we've done the experiment? We've carried out the research. We've gotten our data, we've analyzed it, we've made inferences, we've been able to answer all our research questions. We've been able to treat the scope of the research and all. So what you are left to do now is to publish the findings so that it can be of use to the scientific world. So this brings us to having this session this session on scientific research writing and publication. And to handle this session, we have in our midst today a researcher with numerous publications, I must say, and also is the founder of BCRIS Academic Consults. It's a consult that is a community that provides consultation to students, especially undergraduates and even postgraduate students. So on the academics, so now they are going to excel academically. So we have in our midst today Mr. Christopher Oluwoshoke. Good day, sir.
Thank you, Mr.
Thank you so much for joining us, sir. We are so glad to have you. All right, so I think the floor is yours, sir. So one thing, guys, Mr. Christopher is not joining from Nigeria, so we can tell that our own timing is not the same with his, but still is in our midst today to take us through the last session on scientific research writing and publication. Mr. Chris, sir, you have the floor, sir. Thank you very much.
Thank you so much. Good evening, everyone. I'm happy to be here again, once again. I think this is my second time of presenting on DAS-ICON, and it's a privilege to be here once again. I think the first time was last year. I could remember vividly, I still remembered how it went. So this is the second time. I really appreciate the organization and I appreciate the founder, which is Mr. Shegun. I don't know if you know me, but I follow most of your programs and posts on LinkedIn, which is a great platform I would recommend for anyone. So not to waste our time, my name is Christopher Busayo Oluwoshoke. I'm the founder of BCRIS Academic Consult. And at BCRIS Academic Consult, we work with undergraduate students. Most of our services are channeled towards undergraduate related questions in terms of writing reports, teaching how to go about writing theses, learning how to go about placement for internship, for IT placement and all that, and recommendation on how to write research. So this morning, because it's already about 3 a.m. here, I'm going to just be taking us through my topic, which is scientific writing and publication. So I'm going to be sharing my screen now so we can all go get what I'm explaining. And I've been able to simplify it in such a way that it's not going to be complex. It's going to be easier for us to grasp. So is my screen, is it visible?
Yes, sir.
Okay. So, like I've said, BCRIS Academic Consults, we begin in the year 2018 as a student guide consultant for campus-related challenges. But over time, we have been able to expand our service to include providing customers, we call our clients customers, students, basically. And we help them with connecting them with experts, mentors, technicians for research analysis, and also assist with linking them to laboratory across Nigeria, helping them with consultation on thesis writing, project development, and the execution. And this is something we have been doing since 2018. If you are conversant with LinkedIn and Facebook, you are going to see some of our posts. You should get to reach us if you have something related to what we can offer you in terms of our services. Once again, I want to appreciate the body SciCon organization. I want to appreciate everyone that has put this together to invite me to take students on the scientific writing and publication. So today I'm going to be going through these outlines. I just have about 6 outlines here. And from my outline, you can see we are going to be talking briefly about introduction to scientific research. scientific reporting and effective presentation of research findings. We are going to be talking about tips for effective scientific writing and some scientific reports and structures. Then we are going to be going to demonstration of choosing right journal for publication and peer review process and responding to review. So this is basically what we are going to be talking about. And at the end of the day, I know we are going to be understanding what it takes to write a publishable scientific paper and how to go ahead to search for journals that is suitable for publication of such paper. So one thing I used to do during my program or any presentation I make sure to bring up an objective of session so that you are not going to just come to a session and you don't have an idea of why we are doing something like this. Like I said, our organization, my personal organization, which is BCRIS, and I know SciCon also is working ahead to bring about objectives like this. So in this session, we are going to be achieving these objectives, which is one, to promote the act of proper scientific research writing, knowledge, and skills among young scholars. And I believe they are undergraduates here, they are postgraduates here in terms of PhD and masters. So this is one of the objectives that this session is going to be establishing at the end of the day. So the second one is to establish a basic knowledge of the proper use of scientific medium for communicating innovation and discovery that will involve bright mind. I know everyone is bright here, and then our field in which we conduct our maybe undergraduates or postgraduates is diverse. So we are going to be helping us to know how to communicate ideas, discoveries we've made in the lab in terms of writing manuscripts, writing reports, and publishing it. And the last thing is this kind of program I know is going to encourage early mentor-mentee relationship for future generation of scientists that will drive global research practice. So at the end of the day, we are going to come about knowing how we can also establish early mentor-mentee relationship, because the drive of any scientific community now is for anyone that is willing to grow should have someone they look up to. And in this kind of program, I believe we are going to know how to go about doing that. So just to go further into our program of today, the introduction to scientific writing. Now, as you can see on my screen, I have 3 questions here. What is scientific research? Why scientific research and the benefit of scientific research? Now, it is in all fields of study, there is always a need to conduct research. And because there is a need to conduct research, the understanding of this brings about what scientific research really means. So if we want to conduct research, we have to understand what scientific research really means. Now, to an ordinary person or a scientist, if you are going to ask me that kind of question, I'll just tell you this is a unique way of identifying and addressing questions through systematic process of inquiry and experimentation that is aimed to discover new knowledge or validating existing knowledge. Now, in scientific community, the reason why we are conducting research is basically to experiment, check for questions, discover new knowledge, and also validate existing knowledge. But then because I'm a consultant and I've been able to work with a lot of students, basically in Nigeria, I have been able to discover that most of the Nigerian undergraduates to research are something that are not always innovative in such a way that you are going to discover that there is just like a building on knowledge that is already established. That is validation of existing knowledge. That is basically what most undergraduate students in Nigeria do. And it is because I've been able to work with students in Nigeria for over the years, and I've been able to know this. But because this medium or this avenue is a way in which you are going to know how to come up with conducting research, even if it is you validating existing knowledge, you are going to be conducting research that is publishable. And doing this research requires you to know how to go about it. Now, to a layman, this means that doing what others have done for scientific research now, to a layman, it means doing what others have done in a way that has not been done. and in order to get what is known or unknown for the benefit of human. Now, if I'm conducting a scientific research, my end goal is that what I'm conducting a research on is either it is establishing a new knowledge or it is validating a knowledge that might not be known in my own community. So now, if researchers have conducted a study in, let's say in America, for instance, and because that is something that is peculiar to a geographical area, and you want to validate if what they are saying in this place or what they have done in this place is true, you can decide to conduct that similar research and then subjecting your research condition to what they have also conducted in that location. Now, this is you building on an existing research. But then when you come about doing work in such a way that it has not been done before, to establish a new knowledge that is an innovative kind of research. So to a random person is going to say, conducting a research is for you to do it in such a way that's not been done before in order to get what is known or unknown. And there are some times in which you are going to conduct research that has not been done before, that you are going to be coming into to get data, to get information, to get outcome or findings that is relating to what has been known before. So today, the main area that has been shown to evolve in consistent scientific research is the STEM, which is the science, technology, engineering, and mathematics. And some of this kind of research they do are into in the field of medical, technology, biotechnology, microbiology, biochemistry, and etc. So now, why are we conducting scientific research? Right, it's important. The importance of scientific research has been long known in our everyday life. Now, it's not going to be new if I tell you that scientific research has started since the days of the Stone Age, since the day of the Iron Age, since industrialization age. Currently, now we are in the artificial intelligence era. Now, if you ask me, Stone Age, how is science being done in the Stone Age? You are going to, if you check back in time, you are going to understand that there is a way these people get to do things. For instance, from history, it is known that for you to make fire, for instance, you need to strike two stones together. So there is a knowledge behind them getting that idea of striking two stones together to make fire. And for them to just make fire, it requires some other things for them to put in place, like a dry matter, like maybe sawdust, maybe leaf that is dry, or something that is dry that they know that if there is a spark, it's going to conduct heat and it's going to start combusting to bring up fire. So it is important that right from creation, scientific research has been conducted in such a way that it is being developed over time. And now that we are in artificial intelligence era, we should not be conducting research that is of low grade, of low quality or low class. So the way scientific research is advancing today, it is crucial to know that there are multiple reasons for conducting scientific research. And one of the reasons is to drive progress and innovation. Now, in today's world, you are going to see that many of the research that are being conducted now, the essence is for it to make our human life easier and smooth. Now, for instance, let's say when Tesla, the creator of Tesla, that is, what's his name again? This Twitter man, when he developed Tesla, you see that he brought an innovation to machinery, to mechanisms of car driving. It gets to a stage, people start criticizing it. People start saying, oh, this kind of innovation is going to cause a lot of accidents. It's going to cause a lot of issues. But then if you look at the idea behind the technology of Tesla development, it's not because they just want human to be dormant in our engagement with our everyday life. This is because they want to do something that is going to bring us closer to ease, and at the same time, it's going to bring us comfort and bring progress in our everyday life. Now, you are going to see Tesla beyond just it being an automated car that you don't need to start handling the steering for it to move. There is something they develop with it, which is this sustainable battery, which does not require you to use a fuel, or it does not require you to use gas. Most of their cars are electric cars. So this in such a way is bringing innovation in terms of solving problems that is related to carbon emission. It gets in terms of combustion of fossil fuel cars. So this is one of the reasons why we are conducting scientific research. Another thing is to help resolve scientific practical problems and improving the quality of life. Now, if I'm a car driver, for instance, and I have a car, and I know this my car is, I need to go out. I'm still talking on Tesla. Now I need to go out, take customers from one place to another. But then you see that people that are into this taxi business now, they are getting more of cars that are automated. For instance, that might not be something that is being currently in practice in Nigeria, but in a advanced country like the US, like the UK, like Dubai, for instance, you are going to see that most of their taxi cars they don't require human to drive them again. This kind of car is bringing comfort to people that they know that ordinarily they are supposed to be the one driving the car. So people now have time to get away from the steering. The car have to do all this by itself, so it's automated. So this is bringing improvement to the quality of life, at the same time saving the environment. Now, the last one of the other points we need to know why scientific research is being conducted is to advance the understanding of our natural world. Now, in creation, everything is being created for our good. If you're a Christian, if you're a Muslim, we know this in our Quran, in our Bible. This is how it's been said. So if we are conducting research that is going to improve our life, that is going to bring innovation and progress, that means we are understanding how what is available in our natural environment that we have not known. And let me now bring up this instance. For instance, there is, let me say, a microbiologist. Now, at a point in time, for sequencing, the way they do sequencing of our gene or genome, for instance, it is complex and it requires a lot of effort. Now, when it comes to a stage of them developing a PCR, which is an automated replicating tool, an automated replicating system, which multiply genome or multiply genes, for instance, you are going to see they were able to identify some peculiar microorganism that is involved in that process of PCR. Now, this microorganism, it is available in our environment, but through research innovation, these are some of the things that are being understood from our natural environment. You are going to see that with research, there are many things we are yet to know that with consistent research, we are going to start knowing as time goes on. Now, the third thing is the benefit of scientific research. Now, the impact and benefit of scientific research is diverse, and it goes across fields, diverse fields. But as a scientist in the area of science, for me now, I'm going to tell you, if you ask me what is one of the notable examples of science research, I'm going to tell you, oh, do you know when COVID-19 started, for instance? And at that period, we all know there is vaccine. Vaccine is widely used for polio, for measles, for several viral disease at that time. But then, because of COVID-19, an innovation came up, which is the mRNA vaccine, which is one of the mostly used vaccine type that is being used today. But if I'm going to tell you how this vaccine came to place, you are going to be shocked that the vaccine that they used for the COVID-19 wasn't intended for COVID-19 in the first place. And this is because the research that this vaccine is being administered or is being channeled to is HIV/AIDS. But then when COVID-19 struck, they discovered that, oh, they have been conducting a research on developing a vaccine for HIV/AIDS. And they have discovered that this vaccine, which is an mRNA vaccine, they have done the work to a clinical stage, and they have discovered that this vaccine is very useful for HIV. But they have not rolled it out. They have not patented the vaccine. That is the mRNA vaccine. So they now said, oh, if we are able to do this for an HIV vaccine, HIV/AIDS virus, let's try this kind of vaccine, which is the mRNA vaccine for COVID-19. And that was where the success of COVID vaccine came into play. And this is scientific research coming into play. So you can see that scientific research is something that comes with innovation and it comes with improving life. So if that kind of vaccine did not come at that period, There will definitely be vaccine, some other type of vaccine, which is like the attenuated or the ITFix or the other known vaccine. But then in the way that these mRNA vaccine have been able to cope these COVID-19 for the span of 1 year plus, you are going to see it's not going to be this way, because this vaccine for mRNA vaccine is much more potent and powerful than every other vaccine that have been known. It gets now. So this is one of the benefits of scientific research. Now, moving to the next thing I have here is scientific report and effective presentation of research finding. Now, there are different types of scientific research. One of the type of scientific research is the basic, the applied, the quantitative, and qualitative. Now, yesterday, I think Mr. Sheon talked about some of these, so I'm not going to be emphasizing much on this. So I'm just going to be brushing through. Now, for basic research, which is one of the type of research, for basic research, the principle being is that you are going to be expanding on fundamental knowledge without immediate practical application. Whereas for applied research, there's going to be you coming up with specific solution to unique problem that require practical application. And I've been able to give you an idea of what this kind of thing is. Now, for instance, let me give you a basic research. Now, you want to know the gene that is present in an animal. You know, several animals' genes have been sequenced. Many animal genome have been known. Many genes that code for a protein has been sequenced. So these are not research that is really bringing innovation per se. But then these are basic research because it is something you need to know. It's something that you need to do to establish a fundamental knowledge. But then when it comes to applied research, this is where you start coming to solve unique problem, and you are going to be practicalizing it with application that is relevant for a long-term use of humans. And for example, an example of an applied research is when you are investigating drug therapy for cancer treatment. Another example for basic research is when you are conducting or you are just sequencing a gene in an organism. You know, there are several genes. For instance, let me tell you now, you can go to NCBI and you get a gene for, maybe you want to sequence a gene from an organism. You can still get that gene from NCBI or some other database that are available online. But when you now start saying, oh, I want to use this gene to address a problem that is related to a disease, you are now conducting something that is applicable for humans. That is when you now say this kind of research you are conducting is an applied research. Now, in terms of quantitative research, yesterday Mr. Sheon said it. He said quantitative research involves numerical data and statistical analysis, where you start using statistical data like what Mr. Adeniyi has used today, which is the XPSS. Some people use R, some people use for instance, there's this software I use for my data analysis. I don't use SPSS, I don't use R. There's one other software tools that I use for my statistical analysis. So this is what quantitative research involves. Whereas qualitative research involves non-numerical data and thematic analysis, where you start conducting interview, collecting cases, reports. So you are going to be conducting this kind of research. So this kind of research is called qualitative, where you do interview with people. So these are compared by measuring variable and ability to test hypotheses with quantitative and the exploration of complex phenomena, which Mr. Adeniyi has showed us in the use of R and XPSS. So now, how does a scientist report or present a report? So, but before we know, before we ask this kind of question, what is a scientific report? I think that is something we need to know. Now, a scientific report based on investigation I've done, it is a written, recorded, or artistical piece of information intended for a specific or general audience to communicate a knowledge background towards questions or problem and experimentation to resolve this, the general finding, and how this outcome relates to existing knowledge. If you are getting me, it is a written, recorded, or artistic piece of information intended for specific or general audience. Now, if you are conducting a research or you are writing a research report, that means it is a written, it could be in written form, it could be in reported form, recorded form like videos or audios, or it could be an artistic form like a design. If you ask some other field, like in the field of art, I've seen some people do a research or they conduct research where most of their research are artistic. So they are not writing too much story. They just come up with concepts that require them to come up with an art that is going to communicate an information they are trying to pass across. So these are ways in which these are what scientific reports are. And scientific report intention is basically to communicate information on a knowledge background and to answer questions or problems and conducting experimentation that will resolve this problem or questions to generate findings. And when you generate this finding, it comes up to you extrapolating meaningful decision for progress around a field of study. So if I'm conducting, or if I want to conduct or write a research report, I want to record a research report, that means I have to go through this several steps. I have to have a background of what I want to do. I have to have a problem or question I want to resolve. I have to have an experimental design I want to use to resolve this problem. Then I'm now going to be generating my data. And then from my data, I'm going to be getting, discussing what I've gotten and then relating it to existing knowledge. Then I'm going to be coming up with a decision or conclusion that is going to help to push progression of this area of research in my own context. Another person can do research in another field that is going to also follow this trend. So how does scientists present a research? Now, there are several means in which scientists present research. For instance, there is a written presentation, like I've said, and some of the written presentation are journal articles. Now, researchers submit journals in reputable journals, for instance. They submit articles in reputable journals, and some of them we are going to be discussing today. We are going to be sharing some insights into that. Another written presentation that scientists use is thesis and dissertation, and these are written in graduate school or undergraduates. Basically, in Nigeria, we call our scientific report that's been written at the final year thesis. But at the PhD level, master's level, they call it dissertation. So there is difference between that. So you can check out what makes the difference. Another way in which scientists report or present a report is conference paper, which is called proceedings. Now, these are different ways. They are technical reports in which students write during their seminars, during their IT presentation, technical reports. Another one is oral presentation. Now, I've said written presentation. So these are oral presentation. There are times you have to come up to present. Now, webinars like this, where I'm speaking to everyone, I'm giving you idea, I'm giving you concept of what scientific research is a kind of research presentation of what I've gotten so far about this area of study. Now, another one is workshops. Another one is thesis defense, where you begin to say all what you have known or what you've learned about a field of your focus orally. Now, the third one, like I've said, which is artistic. It could be visualized using poster. It could be done using infographics. It could be done using, and the fourth one I have here is the digital presentation, where you are going to be using recorded videos or online seminar. You can watch YouTube's. You can go online, go to YouTube, watch videos. You can go to Facebook, watch video on an interest. You can go to LinkedIn, watch information. Some people even come to the stage of recording this artistic digital presentation as a film. Now, if you go to some field of research, like in the social science, management science, or arts, or this law-related side, there are some kind of research they do that they have to come up with a visual in terms of films or audios, which they will just put out. It's just for you to read or hear what they are saying. So these are ways in which scientific research are being communicated. So, but one particular one I'm going to be majoring on today is the journal article. So the last question I have on this page is what makes a scientific research effective? Like I've said, the essence of you writing or communicating the research is, for you to communicate a knowledge. And while you are communicating the knowledge, that means you have an intended receiver and you are the sender. So there is a link between the writer and the audience. For instance, let's say I'm writing a research in the area of COVID-19. So if I'm going to be writing a research, that means my audience is going to be people in the field of virology. or people in the field or area of immunology. So there are specific audience in which your kind of research is going to be targeting, which are the audience. So for a report to be effective, there must be communication, and this entails sharing meaningful findings between a sender, which is the writer or scientist in these terms, and receiver, which is the audience or science community, for instance, usually to a broader audience. So, and there are some times in which you are going to write research that you know that it is relevant not just to a specific field. Now, for instance, let's say COVID-19. When COVID-19 started, you are going to see that several fields of interest are involved in terms of health, in terms of law, in terms of security, in terms, name it. Some people are coming up with ideas. For instance, when COVID-19 started, scientists come up with meetings. They decided that, oh, we need to put on nose mask. They wrote all this, they publish it on blogs. Now, other field like, let's say the journalists, for instance, they pick this information and bring up artistic representation of these things. They are able to communicate it to a wider audience. So you can see these are science, or these are ideas, these are knowledge that are being communicated to a wider range of people. So you have a specific audience in which you are communicating your research to. So if your research will be effective or your report will be effective, that means you must be communicating something that is understandable, something that your audience can see and say, oh, this is what this person means. So because there is not going to be a lot of time for them to start sitting and hearing or seeing or trying to know what you are doing. So what you are doing, you are going to be compressing it in such a way that it's going to be, let's say, for instance, for journal articles that are original papers for at least 5,000 words. And this, what you are conducting now, many of these people will not read it. So there are ways in which some other expert is going to help you bring this into a short video of, let's say, 1 minute, 2 minutes, and communicate, help you communicate to the audience. So these are ways in which your research needs to be effective. And the basic is the communication medium in which you are using. So the next thing I have here, I have tips for effective scientific writing. Now, there are several tips. But because we are not going to be discussing them comprehensively, I have 1, 2, 3, 4, 5, 6 tips here. Understanding the kind of research you want to conduct. Now, like I said, as a scientist in the area of biotechnology, for instance, I'm a graduate of biotechnology, but then my research area is my research is in the area of use of natural compounds, therapeutic natural compounds for the treatment of a particular disease. And this kind of disease I'm interested in is diabetes or cancer. So now I understand that whatever I want to do, whatever I would want to do now or in the future should be in the field of cancer or diabetes. So I understand the kind of research I want to do. Now, since I understand the kind of research I want to do, I have to provide adequate context of what I want to do, for instance, if I want to start writing. Now, I know cancer and diabetes is a wide field, but knowledge are already known in cancer and diabetes. Established facts are known, established theories are known, established hypotheses are known. So, but then there are still some particular areas that has not been addressed. There are some specific area that has not been hammered. Now I want to go to say, oh, let me now read literature, let me consult papers, let me consult articles to see what the world is still suffering from. And it will shock you that because I know that disease like cancer and diabetes is still causing, or is still one of the highest cause of global death. That means even with the number of research that are available, people are still dying from this disease. That means there's still need for more solutions, provided that I'm going to be conducting a research that is meaningful. It is not like there is no solution, but these solutions that are available are not 100% eradicating these issues. So whatever I'm going to be bringing up as a scientist, providing context that I want to do in this area is going to be adding to the body of knowledge. So now I'm providing myself with adequate context of research I want to do. I know what is happening. I know where it is happening from, and I know where this thing is rampant. So it's going to be surprising to you that the way we are saying malaria is killing people in America, in Nigeria, it's not the same way it's killing people in US. The way COVID-19 killed people during that period in US, it was not the same way it killed people in Africa. So now this kind of research, you are going to see there is variation, there is differences in which this research is going to influence particular area or locations. But because I'm a researcher I'm a researcher in the area of diabetes and cancer, and I know that cancer is a global disease. Diabetes is a global disease, but then it is limited more to areas where there is rampant obesity, for instance. There's rampant consumption of sugar. There's rampant consumption of glucose, those kind of things. And I'm now going to start bringing up or coming up with idea of, oh, this is my research. Is it that I want to conduct a research that is specific or relevant to Nigeria in the terms of cancer or diabetes? Is it that I want to conduct a research that is going to be facing America, or I want to pick data from America and compare it to what is happening in Nigeria? So this is a way in which I'm going to be coming up with adequate context. Now, providing thorough logical flow. Now, because I want to conduct a research now, I need to know some things. I must know that my research that I want to conduct must be clear and concise. There must be clarity. I must use simple and direct language to convey my idea, for instance, when I start writing, because this is a scientific tips for effective scientific writing. No, the first 2 points is me knowing what I want to do. Now, this third point, which is providing logical flow, is when I start knowing, oh, how do I put this down? And I say one of the points is me being clear and concise with what I want to communicate, using simple and direct language, for instance. Now, to be concise means, let's say when I'm writing, I don't want to start using redundant words that are not, that they are going to be causing confusion to whoever is reading it. I might be writing a word and know that in the scientific community, people might understand it, scientists might understand it. But because I want people, a wider audience to understand it, I'm going to be using clear and concise words. Now, another thing to note is that for me to have a logical flow, I have to write a kind of research that is going to be using active voice, engaging with my writing skill in such a way that whoever is going to be reading it will know that, oh, this person is writing this research in such a way that we know is the one that conducted it. It's not that he contracted it out. So this kind of this is where you start, I say, you start using active voice. Now I'm maintaining logical flow. Now there is a specific structure into which research writing are being organized. So there are several types of research report. There are several types of structure, which is the next slide I have after this, but I'm going to be discussing that. So for your logical flow, you need to organize the kind of research you want to write. If you're writing a research that involves you to conduct interview, you know the kind of research you are going to go for. If you are writing a research that is going to require you to start saying you want to do experimental work, you should know what you want to go for. If you are conducting a kind of research that is going to require you to go to databases, pick the work that has been done, shovel them everything, and come up with a report that is going to say, oh, this is what has been known in this area. There is a kind of research that is done like that. So these are logical flow. These are structures in which you need to put in place for you to know that, oh, this is the kind of research, or this is the flow in which I want to go with my research. Now, precise data presentation. You know, this kind of, at this point, you are already generating data. You already know what the question you are resolving or the question you are answering. You already have idea of what you want to answer. You already got your data. Like, let's say you've gone to the lab, you have conducted experimental work. Now you are generating data. You might be doing a qualitative work. You might be doing quantitative work. You might even be doing applied research. So at this point, you already have your data. You already have the knowledge or established knowledge or questions or problem you want to solve. Now, the next thing is to also know that for your research or for writing a research, you must follow some ethical guides. Now, if you are conversant with what is happening today, you are going to see that many people are coming against or backlashing the use of AI in scientific research, which is one of the ethical concerns that we have today in research. If you're writing a research and you discover that you need to use AI tools, of course, everyone uses AI tools. Yes, everyone uses AI tools to write. For instance, Grammarly is an AI tool, but Grammarly is used to correct grammars. So most of the time we overlook it, that it is not AI tool. Some people will even tell you it's not AI tool, but Grammarly is an AI tool, a tool that is helping you to correct your English, your blunders, grammatical errors. It's an AI tool. So people overlook that. So now, because there are tools like ChatGPT, there are tools that there's even a tool that is being, I think, a new tool that is being put out by In Silico Medicine. That tool, you don't need to write if you want to write a manuscript in less than 10 minutes, that tool will write everything for you from the title to the conclusion and your references. You can see people are they are conducting research in such a way that is going to make life easy. But then, because you want to write an effective scientific report, you need to follow some ethical guides. So some of the ethical guides, there is a specific degree at which you are allowed to use AI to. For instance, some scientific journals, I'm going to be showing now some of them, already said, if you are using AI tool in your paper or in your writing, indicate that you use AI tool so that it's not going to be flagged as an offense. If you say you use it, now people are not saying it's an offense again, because it was when it started, or when people started using it, they were fighting against it. But now, because people are used to it, and something about the word is that when people start saying something, when it comes to 2-3 months after that, people will forget it and move on. So that is how the word is. That's how human race is. So, but then there are some ethical standards you need to follow. Like when you are using animal model in your research now, they will tell you you should treat this animal like they are your children. You should treat them as if they are humans. They have feelings. They can feel pain. They can feel stress too. So you have to treat them with respect. You have to treat them like you would treat a human being. So these are the things that you also need to do when it comes to AI, use of tools like AI too. So these are ethical guides. So this is more complex and that we cannot cover today, but this is one of the tips you need to follow. And the last thing is, while you are writing a scientific report, you need to know how to use a proper citation. Now there is in-text citation, the bibliography, and that is another thing for another day. So if you are writing a research and you are not properly citing ideas, properly citing articles where you are getting this the knowledge you are putting together, it's going to be an offense. And there is something they call plagiarism, where you start copying and pasting, for instance. There are different types of plagiarism. We are not going to be talking about that today. But then another tips you need to know is how to use a properly used citation tool. How to properly use citation tool. And there are several tools in which they use for citation too, but we are not going to be discussing that today. So the next thing we are going to be discussing is some scientific report and their structure. Like I said, there are several scientific reports structure, like review study, correspondence, original research, case study, systematic review, method and data paper, letter to editor, opinions, commentary, perspective. Now, for all this scientific report and structure, there is a particular structure in which you must follow. For the scientific report, you need to have your title, and your title must be clear, concise, and reflecting the main topic or scope of your research. Now, I think when I was in 300 level in FUTA, I did this course. And in that course, it's the title of the course was I think biotechnology research or something. And in that course, the lecturer told us that if you are writing a research and your title is more than I think 20 words, it is not professional. And today, when I look at that kind of that knowledge I got from that class, I have been able to come to notice that there are several scientific papers that are available online that even their title is more than 25. Now you can see, but then one thing I made mention is that your title must be clear and concise. Now, if you're writing a title that is ambiguous, that is longer than 25 words, but it is not communicating anything or it is contradicting, that means your title is not meaningful. And it is outside this, or it might be outside the scope of what you are trying to communicate. So that is why the man said it should be less than 25 that day. So that means if you have little words or limited words for your title, your scientific report, that means you are going to write the title in such a way that it's going to be more meaningful to whoever is writing it. Because if you're writing a title and it is more than 25 words, the truth is, for real, if you're reading it, it's going to get to a stage you're going to look at what's the meaning of all these words. It gets now. So your title must be concise, It must be clear and reflect the main topic. Now, this is one of the structure that is relevant to any of these scientific reports. Now, the second thing is the abstract. I know many of us know what abstract is, which is the brief summary of the research that include the background, the method, the results, and the discussion or conclusion. Most of the time, discussion is not always present in abstract because it's a summarized area of what you have conducted. And sometimes you are going to see that some journals will tell you, or some scientific reports will tell you that, oh, in this your scientific report, you should not write more than 250 words, or you should not write more than 300 words. And there are different types of abstracts. There is structured and there is unstructured, which is not what we are doing today. But then you should know that after your title, you should know the next thing is your abstract for any of these kind of scientific reports. Now, the next thing is the introduction or background of research. Now, this background provides you with the context of the research. Sometimes, depending on the kind of research you are conducting, your introduction could come up with a breakdown of review. Now, if you are conducting, for instance, an original research, which is what many people do today, some people do literature review, and there are several types of literature review, which is not what we are doing. Some people do. I know many of us we know what original research is. We know what literature review is. Now, for scientific reports, we should know that it could be breakdown. Our introduction could be broken down to the background together with the literature for original research, because in an original research, you don't have the time, you don't have the space, you don't have the avenue to write too much information. So you are going to be compressing something that you can use over 15 pages to write, which is the literature review, compressing it down into the introduction session. So this place, you are going to be highlighting relevant previous studies for scientific reports. Now, scientific reports are different. There are several types of reports. There is thesis. You can see I did not write thesis here, but because what we are discussing or what we are talking on today is on publication. So I narrowed down what I'm presenting now to some of the publication format, which is review, correspondence, original research, case study, systematic review, methods, and all that. So for this introduction session of a report, which is either original research, you need to compress information down that is going to also involve literature review on existing knowledge. And here you are going to be writing your hypothesis. You can be writing your research question. You can even put objective or significance of research. Now, there are some journals that I've published that I discovered that the way they wrote introduction in this journal is different from the way they wrote introduction in another journal, which is one of the things I'm also going to show us today, if there is time. So now the next thing after an introduction for our scientific report is method. Now, this is scientific report for original research I'm discussing now. I'm not discussing for thesis. I'm not discussing for dissertation. I'm not discussing for any other report. I'm reporting for original research, which is article for publication. Now, the next thing is method, like I said. Now, this method session details description of experimental design and procedure. Now, in this place, you are going to be talking about the material you use and the method or equipment you use and the data analysis. So most of the time, you are going to see some articles, original research that are structured in such a way that you are going to see the heading as material and method. Some of them will just put material and methodology. Some of them will just put methodology, depending on where you want to put your research. You get now. But then the essence of this place is just to detail description of your experimental design. List the material you use, mention the method, and then you also list the data collection approach you use, data analysis approach you use. And the essence of this place is that whoever is going to be seeing your research or whoever is going to be reading your research is going to be able to replicate it. So that is the essence of methodology. The essence of methodology is to ensure reproducibility or replication of research, so that people can confirm if what you have done in your own place or your research lab can also be replicated in another lab. You get now? So that is the essence of methodology. Now, for results, which is the next thing, this presents data that are generated during the research using tables, using graphs, using charts, using illustration, objective report without interpretation or bias. So in this place, you just write out your results, some of which Mr. Adeniyi has shown us today how to come up with generating some of our data using statistical tool like R and XPSS. Now, the next thing is the discussion session. The discussion session is going to show us interpretation of our results, what our results really means. And when we are discussing our result, that means we are going to be comparing with previous knowledge, previous research, previous theories, just to establish a fact that, oh, what I'm getting in this my research is something related to what has been known before. Or what I'm getting in this my research is completely or entirely new to what is being known before. So the discussion session is going to help you elaborate more on what has been known and what is not known. So this is where you start addressing those questions you have raised. You get what I'm saying? So this is the another portion of your science report that is used for original research. And the other part is the conclusion. This is where you summarize your key finding. You talk about your significance. You are going to also, for instance, some of them will tell you to write limitation or recommendation. Yes, there are scientific reports like that will tell you to summarize. But because this is a structured work that is limited in words, like original research, they are limited. Most of the time you see original research, they will say less than 3,000 or 5,000 words. For review, for instance, they will say less than 5,000 or 7,000 words. So it all depends on the journal you want to publish. So, but we have not gotten there. So for the conclusion, you have to come up with summary, recommendation, or limitation in which you have encountered, so that whoever might be coming up to conduct a research similar to yours is going to have an idea of what you encounter. And the last thing is the references. So in this place, we are going to be having the list of all structure cited sources, and it's going to be coming up with a specific format. So there are several formats in which people use to cite scientific reports that is being consulted. So all these things I've made mention: the title, the abstract, the introduction, the method, the result, discussion, conclusion, and reference is peculiar to all these things. It is peculiar to review, it is peculiar to correspondence, it is peculiar to original research, case study, and all that. But then, the only difference in some of these things will just be something limited. For instance, let me say, for literature review, for publication of literature review, there is specific word count. So the word count for literature review is different from the word count of original research. The word count for methodology and data paper is different. Now, for instance, every researcher can write a review, every researcher can conduct an original research, but not every researcher can come up with an opinion. So most of the time, opinion paper, perspective, or commentary are written by researchers that are not in their early career phase. These are people in the medium or the late phase of their career, like professors. Now, let's say there is a trending area of research that people are not talking about, or people are not conversant about. And an expert, a professor in this area, discovered that, oh, this is something we need to start talking about, or this is the area we need to start channeling our research into. A researcher or a senior professor can come up with an opinion paper, which is always like 1 page. You get what I'm saying? So each of these scientific reports are different, and the structures are different from one another. But then, because of this session, I'm just going to be discussing about original research. Now, choosing the right journal. Now, there are several means, there are several ways to choose the right journal for your publication. And one of the main things that is known is for you to check for the scope and aim of a journal. And I'm going to be showing you my screen now. I'm going to stop this sharing this screen, and I'm going to show you one of my one particular journal, which is Informatics in Medicine and Law, so that you are going to see what I'm talking about. I'm going to be sharing my entire screen now so you can see everything I'm saying. Okay. Can we all see my screen now? Are we following me, please?
Yes, sir.
Yes, sir, we can see your screen, sir.
Okay. Now you can see the first thing I have here is the scope and aim. Now, the essence of your scope and aim is to know what a journal or a place you want to publish, what their focus is. Now, this is an example of a journal. This is Informatics in Medicine Unlocked. Now, if you look at this journal, you are going to see something. You are going to see about journal. This is viewful, aim, and scope. Now, I want to publish a paper in an area that I feel is relevant to computational biology. Now, if you look at this paper, you're going to see Informatics in Medicine Unlocked is an international gold open access. Now, informations are here that you need to pick so that you can know if this is a place you can publish or this is not a place you can publish. IMU is an international gold open access journal. When they say something is gold open access, it means you need to pay before you publish. That means whatever you are publishing is open access, but you have to pay. Now, that is covering a broad spectrum of topic. That is one thing you should know. That is one of the scope. Covering a broad spectrum of topic within medical informatics, including, but not limited to, paper focusing on imaging, pathology, teledermatology, public health, ophthalmological, nursing, and translational medicine informatics. The full paper that are published in the journal are accessible to all who visit the website. That is where this gold open access means. Because if you are publishing a paper in this IMU, you have to pay a particular amount of money, which they call APC, article processing charge. So if you are published or you publish anything here, anybody can access it. That is the essence of the gold open access. But then this paper is covering this scope. That is medical informatics, including nursing, some public health, some pathology, translational medicine informatics. Now, you are going to also see some other informations below. Now, manuscript exploring the revolutionary advances being made in the application of the computer for the field of bioscience and medicine can be submitted to the journal. Now, there is a companion journal that is related to this IME, which is Informatics in Medicine. It is called Computer in Biology and Medicine. So this is another journal they are recommending, that if you want to publish a work in computer application to bioscience too, you can also use this journal. So that means this is their sister journal or companion journal. Now, only manuscripts of science sufficient quality with scientific relevance will be considered for publication. So if your scientific report or your manuscript is not of quality and it is not relevant to this area they have mentioned, they will not accept it. Now, the type of article accepted include original research paper, review, perspective, letter to the editor, editorial, tutorial, and paper on innovative and topical new technology. Now, you can see in this place, they did not mention systematic review, but they mention review. That means you can submit a narrative review. You might not be able to submit a systematic review. And from one of the things I made mention here, let me go back to the other page. From one of the things I made mention here, I made mention of method and data paper. You can see they did not mention method or data paper here. So these are papers you can only publish in this page. Original paper, review, perspective, letter to editor, editorial. Now, manuscript, are you saying something?
My own is not sounding at all.
Can you hear me, please?
No.
Oh. What of now? Can you still hear me?
I guess the
Hello?
issue is from the person's end, because I
Okay.
think other person can hear you.
Okay. So now, if you look at this journal, the last thing on this place is manuscript referee will be experts in the subject area. That means people that are going to be reviewing or people they will be inviting to review is going to be experts in the subject area. Working in academia, industry, and at government institutes. Usually, comment for 2 to 5 referee will be returned to the authors after first submission to the manuscript. Average turnaround time for manuscript evaluation is expected to be less than 4 weeks. So this publication or this journal, they have told you everything you need to know. Their scope, and the aim. The aim of this journal is to publish paper like original review perspective that is of sufficient quality with scientific relevance, and the scope is within imaging, pathology, public health, nursing, etc. Anything that has to do with computational related field. And another thing you should take note is that they publish a good open access. So that is the aim and scope of this journal. So the next thing I have here, the next point I have here is the published peer review process. Now, this is one thing you need to know. Now, you are going to notice that several journals require that when you submit to them, your paper must go through peer review. And there are several types of peer review and different types of peer review. There is single anonymous peer review. There is a double anonymous peer review. There is triple anonymous peer review. And there is open source peer review. Now, a single anonymous peer review is that the reviewer for a paper is not going to be known. You get now. Let's say you are submitting a paper to a journal now, and the journal is inviting a set of reviewers. So the reviewer, the author is not going to be knowing who is going to be reviewing it, because this is going to either bring bias if they are able to, if the author knows who the reviewer is. This can either cause bias, or it can cause a compromise to the decision of the reviewer. So this is a single anonymous peer review. The double anonymous peer review is that the author of that paper that is being submitted and the reviewer are not going to be known. They will not know each other. You get what I'm saying? For instance, you are going to see, I don't know if some of us have submitted a paper here. You are going to see that some paper, when you submit it, they will ask you to write author's information in another document and submit it separately. You get what I'm saying? So those kind of paper are double blind. The authors, they will not know who the reviewer is. The reviewer will not know who the author is, because the information about the author is separated already from the manuscript itself. So they are just going to be sending the manuscripts to who the reviewer is, and it's going to be coming up with a review that you are going to need to address. So that is a double anonymous. The triple anonymous is now the one that the reviewer, the authors, and the editor of that journal, they will not know themselves, in such a way that editor will not know who is submitting the paper. Ordinarily, editor is supposed to know who is submitting the paper, because you are sending it to them for them to publish your work. They have a tendency to know, oh, this is the person submitting the work, when you are using either a single anonymous or double anonymous. But when it comes to triple anonymous, author, editor, reviewers, they don't know themselves. Nothing is going to let them know, oh, who is this paper belonging to? Who is reviewing this paper? Or this? None of them will know each other. So this is the triple anonymous peer review. And then the third one is, the fourth one rather, is the open peer review. And I'm going to be showing us I'm going to be telling us, rather, I'm not showing him. Some journal or publisher that use open peer review is the Frontier or MDPI. So this peer review, open peer review, you are going to see everybody is going to know each other. You are going to know the editor that is assigned to your paper. You are going to know the reviewer that is assigned to your paper. So this one you can easily influence. But then the essence of this is to bring about a collaborative way, such you can express your concern if maybe the editor, the reviewer is saying something that is not, you think is not relevant to your paper. And there are some times in which journals like that or publishers like that, they have reported success in using an open source peer review system. So these are the 4 types of peer review system. And the essence of peer review is for you to make, or for a journal to publish a much more high quality paper. And this is going to require expert, like I said, in a particular field to check through, read the paper, see, oh, this what this person have said. Okay, this is something of high quality. Oh, these are the errors, these are the mistakes, this is what this person needs to fix. So that is the essence of you coming up with a peer review process. Now, another thing you need to know if you want to publish or you want to choose the right journal is publisher credibility. Now, there are diverse publishers, several publishers that are known, available now. And one of the publishers today is Elsevier. I know many of us have heard Elsevier. I know many of us have heard Scopus. I know many of us have heard Taylor and Francis. I know many of us have heard Sage. Many of us have heard of Wiley. So these are publishers that are credible. These are publishers that are credible. These are publishers that are highly, they have large amount of journals that are linked with them. So if you need to publish or know a right journal, you need to have an idea of the publisher. And one of the highest known publisher is the Elsevier, the Taylor and Francis, the Sage, the Wiley, the Springer, and there are diverse type of Springer. There's Springer OpenLink, there's Springer Nature, and etc. So now these are some of the publisher you need to look out for. There's another publisher, they call it, I think they call it Oxford. So now if you are seeing a publisher that is completely different from all this, you need to question if they are credible or not. You need to question if they are credible or not. And one way you need to know if they are credible or not is to ask questions from people you know that are already publishing, or people that are your mentors, your seniors, so that you don't go and publish or go and put your paper or article in a place that is predatory. Now, another thing you need to know or you need to look out for when you want to choose a right journal is indexing. Now, many people will tell you there was a time when I started publishing, I have no idea of what indexing is. And indexing is these are platforms in which a paper are being deposited so that people can see it. Experts can see it, researchers can easily access it. And one of the widely known indexing platform is Scopus. So I'm going to be showing us an example of what an index looks like. So this is informatics in medicine and medicine on law. I want to see the index. Now you can see this journal, this is the editor-in-chief, this man. So they have simplified it. They also give you information about the amount you pay. Like I said, when we check it the other time, article processing charge, it is $2,330. So if you have this money, you can pay. If you don't have it, you have opportunity to look for other journals. And I'm going to be showing us how to look for journals that is suitable for publication of our paper. So now I want to show us, these are some of the recent articles that are published. Article in press, top cited, blah, blah, blah. So I want to show us index of journal. Now, if you want to know how a paper or how an article is being indexed, there are several ways you can know. You can either come through this place through this guide for author to check information about indexing. I'm trying to look for that. Okay, let me come to this place. Okay, Journal Insights, about. So I'm going to click on Journal Insight and I'm going to see information about everything that is relevant to this journal. So this is the abstracting and index. Now, like I said, there are several indexing platforms. One of them is Scopus. Now, if a journal, most of the time, experts or researchers that have used longer years, they will tell you if a journal is not indexed on Scopus, if it is not indexed on PubMed, if it's not indexed on Medline, that three, Scopus, note it down, Scopus,
Medline, PubMed. If it is not indexed, most of the paper, that journal, it is not, they see it as journal that is not credible. It doesn't mean those people don't publish there. People feel if your a journal is not indexed in these 3 platforms, it is not credible. And another one they used to also look is the Directory of Open Access Journal, which is the DOAJ. So these are some of the things you need to look out for. So let's say I want to look for another journal, for instance. Let me say this recommended sister journal that this informatics is showing us, which is the Computer and Biology and Medicine. So I want to see the index of this journal, the abstract and indexing. So if you look at this, you are going to see the abstract and indexing of this one is having Medline. It's also having Scopus. But this one, Informatics in Medicine, it is only having, just a minute. It is only having Scopus. It is not having Medline. So it's having Scopus, it is having DOAJ. But then Computer and Biology and Medicine is having Scopus. It is not having DOAJ. So these are the things you need to look out for when you are picking journals, when you are picking where you want to publish. These 3 indexing, Scopus, Medline, and PubMed. If you do not see that any of those 3, you are likely to be publishing in a way where your paper or what you are publishing is not going to reach a wide audience. Or either you are publishing in a place that is not credible. Now, if it is not indexed in Scopus or any of these 3, it doesn't mean it is not credible, but there is likelihood that it is not credible. So you should always look out for Scopus, Medline, or PubMed. Now, another thing from my table here that I have is quality of previous publication. Now, if you see a journal that you want to publish, for instance, let me go to Informatics in Medicine and Law, the home page. You are seeing a journal and you are not seeing something like this. Latest, article in press, top cited, most downloaded, most popular. And when you read, maybe let's say you read one of the paper, which is accessible because this is a gold open access. That means you can download any paper here freely because the authors already pay. If you're opening a paper and you're not seeing that it's well structured, or it is written in such a way that it is having, you see some paper, you open it, you start seeing error. You start seeing there is shrinkage of space. The paper is not well written. That means you should know that the journal is not credible. So you should look out for journals. You should look out for journals that have low quality publication. So you have to look out for previous publication quality. So this is for Informatics in Medicine and Law. So let me also check, or let me show you previous articles that have been published on Computer and Biology and Medicine. Now you can see this is the latest, top cited, most downloaded. You can see in this place, these are papers that I cannot access because this journal is a support open access. Now there are different kinds of open access. There is gold open access, there is support open access, there is hybrid, and there is supplementary. Now, when you see a paper saying good access or support or open access, listen, please. When the paper is telling you open access or good open access, that means you need to pay. When the paper is telling you support open access, hybrid, or subscription, that means you can either pay or you don't pay if you want to publish with them. And when you don't pay, that means whoever is going to read your paper will need to pay for them to download. For instance, how do you know if a paper is easy to download or not? You are going to see that at the end of the paper, they are going to write open access. But you can see this research article, there is nothing like open access. Now look at this one that is here. You can see research article open access. This is for Computer and Biology and Medicine. So let me go to Informatics in Medicine and Law. Now you can see that because this is a paper that is open access, that means before you can publish here, you need to pay. That means definitely all paper on this platform is free. You can download it. So you can know
because you can see open access here in the front, and you are going to see something like a green button. You can see open access, open access, open access, open access, open access. So everything here, before these people that publish here, they can publish, they paid. But for computer medicine and law, which is support open access, I said you can either pay or not pay. So if you are not paying to publish here, that means whoever wants to read will be the one to pay. So this is an evidence. Let's say I want to click this paper and it's not showing open access. How do you know that this paper, I cannot download it? You are going to see, they'll ask me to access through my school, or I should pay for it. I should purchase. I should purchase. You see, they ask me to purchase. But I want to look for paper on this platform that has been paid for, that I will not need to pay. How do I know? I'm going to see open access, and you can see view PDF. So I'm just going to click this. When I click this, you can see it's already showing me to view PDF. That means I can download this paper without me stressing. That is because the person that published this paper paid for it. That is support open access. You can either see it as support, you can either see it as subscription, you can either see it as a hybrid. So different journals have different way they write it. But what it is, once it is open access or good open access, that means you need to pay. There is nothing you can do. So this is how computer medicine looks like. Computer and biology and medicine. So now the next thing we need to look to is check Bell list for predatory names. Now, there are several papers, there are several journals. I don't know if you are all conversant with it. When you check your email, some journals will send you a message. They will tell you, oh, dear Dr. Sharif, dear Professor Sharif. I don't know. Is there anyone that have come across that before? Anyone come across that before? Dear Professor Sharif, we have been able to see some of your previous publication, and we are inviting you to submit a paper to our journal. Have you seen it before? Have you come across that before? Anybody?
Yes, I think I've come across one of them.
Yeah. So these are papers. They will even tell you that you don't have to pay. Many of them are predatory journals. But then there are some papers that also, there are some journals that do like that. There are some journals that do like that, but to some extent they are credible. For instance, Frontiers Journal, MDPI journals. You get what I'm saying? There are some publishers like MDPI that are credible, that also do that kind of thing. But once you see a journal that you have not heard of the publisher before, you've not seen the name before, and they are sending you that kind of emails telling you, dear professor, so, when you are still an undergraduate, you feel like, oh, this person is trying to cajole me. So if you see page journals like that, you need to just pick the name and you go to Bell Lists. This is a platform where you can check for all known predatory journals, all known predatory publishers. And this is what Bell platform looks like. Bell Lists. This is what it looks like, where you can check for potential predatory journals and publishers. You can check for predatory journals and publishers. So I'm going to be opening this so you can see. So these are potential predatory scholarly open access publishers. So there are several lists. These are some of the publisher lists. So when you see a publisher that is named ABC Journal Publisher, when you see a publisher as academic journal, these are predatory journal. When you see them, you should run from them. That is what they mean. You can see it's a lot publisher. A lot of publishers that are predatory. They are fake. They just want to collect your money. And another way you can easily know a predatory journal is when they ask you to come and pay, and they are telling you, oh, come and pay just $50. Now, for instance, let me show you something now. Look at this journal, Informatics and Medicine and Law. How much are they saying anybody that wants to publish here should pay? They said 2,330. But you are now seeing a journal that is telling you to come and pay $20. Now, compare it. They know you will rush. you want to submit your paper, even if it is nonsense. And in that sense, you are going to also notice that some of these predatory journal publishers, they don't have a well-structured peer review process, which I've made mention of. They don't have a very refined scope and aim. Their publisher credibility, when you look at their previous work, previous publication, you are going to see that it is either one or two. In the year 2023, go and check, you will see maybe 3 papers they publish. You see another year, 2001, they will publish 1 paper. You can see there is inconsistency, a very low quality of papers being published. So these are the ways you need to use, you will use to know the right journal for publication. So the next thing, to elaborate what a peer review is, like I've said it the other time. A peer review is a systematic, is a system in which a journal or an article is being checked by experts in the field or a field of interest to improve on the quality and the relevance of what you are intending to publish to a journal article. And then there are the several types. I may mention of a single, a double, triple, and open peer review. And I've mentioned the differences. Now, the bias, there are bias in each of these type of peer review. But then the essence in which a peer review is being conducted is just to improve an article before it is being accepted for publication. So I want to know, for instance, let me say I want to know information about a journal, how if they are publishing using a single, double, triple, or open peer review. So this is informatics in medicine and law. So I'm going to see, you can see about the journal, this is the aim, this is peer review. So in this place, you will see they said, this journal follow a single anonymous review process. Single anonymous review process. And then for you to, that means this paper, you are the author, for instance, you are the one submitting, the corresponding author is submitting. That means the editor, the reviewer is not going to be known. That means you will not know who is going to review it. That is the meaning of single anonymous. It is that reviewer that is anonymous. That's the meaning of single anonymous. The reviewer is the one going to be anonymous. That means you will not know who the reviewer is. There are some journals that even ask you to suggest a reviewer, but when they pick a reviewer, you will not know who it is. So this is meaning of single anonymous. But double anonymous means the reviewer will not be known, the author will not be known by the editor. None of them will know each other. That means there is a process, there is a way you are going to submit in which you are not going to be incorporating the author's information in the manuscript itself. You are going to be separating it. So now, in this informatics in medicine, they use single anonymous in which the reviewer will not be known. So for computer in biology and medicine, we want to see if what their peer review process is like. The author's information in the manuscript itself. Informatics in medicine, they use single anonymous in which the reviewer will not be known. So for computer in biology and medicine, we want to see if what their peer review process is like. I think I'm hearing myself. So now okay. Okay. So now this is computer in biology and medicine. I want to see the peer review process. Now for informatics in medicine or law, it is single anonymous. But then for this one, we want to see, this one is also a single anonymous, meaning whoever is going to be reviewing it will not be known. So now there are other information about peer review that you need to know. If you want to know what peer review is, you can go over to read this, check the peer review process, type of peer review, and article transfer process. So for you to pick a journal, you should also know that the journal must be conducting a sufficient peer review process. Now, going down to selection of journal. How do you select a journal? Before we go to the highlights? Now, I'm going to be showing us, and I'm going to be sending the link for, I think 4 or 5 platforms in which you can use to check for journal that is relevant to whether what you want to publish. Now, I'm going to show us for Elsevier. Now I'm going to copy this platform and share it in the chat box so that we can also have access to this. We can have access to this. So this is Elsevier. Now I want to publish a paper in Elsevier because Elsevier is a reputable is a well-known publisher. And Elsevier have several journals underneath it. But because I'm a scientist in biotechnology, I have conducted the research in my lab. I have done data analysis. I have written the manuscripts. I want to publish. How do I go about publishing? That means I need to know the right journal. Sir? Yeah?
Sorry for interrupting, sir. We have 15 minutes left for this session, sir.
Okay, I'll be fast with this. I'm
Alright,
going to be selecting the right journal. And for me to select the right journal, I'm just going to be showing us an example. Let's say I have a manuscript. This is a typical example of a manuscript I have. This is the title of the manuscript. Now you can see for this Elsevier journal, they're asking me to put the abstract. That means I've conducted my research. I want to use the abstract to check for journals that I can publish my research. That's the meaning. So I'm just going to use this as an example. Let me pick this abstract in this place. I'll pick this abstract, and I pick this abstract. I'm just going to copy it in this place. I'm going to copy it in this place. So because I've copied this in this place and I want to find I will just use match my abstract. I will use match my abstract. So the next thing for me to do is to find journal. So this is going to recommend several journals for me, and it's going to be using a specific algorithm. Now you can see at the left side of my page, I have publication type, open access and subscription. You can see this is marking yes, and this is marking yes. And I have 38 journals suggested for me. You can see. So now, because I'm a scientist from Nigeria, I don't have money to publish. That means I will not be looking for a journal that is open access, which will require me to pay money. I just need subscription. So I'm going to uncheck this. So it will reduce, it will off it. So I want to see how many is remaining. I have 28. Previously, it was what? 23 now, sorry. Previously, let me check it again. Previously, it was 38. That is, it's having open access and subscription. But when I uncheck this open access, it reduced down to 23. That means any of these journals, 23 journals that it has suggested for me, I can submit, I can publish there without paying. So it has open access and subscription. See this one, open access and subscription. That's the meaning. So that means all these journals having either open access or subscription format. So now what is now left for me to do is now to check for information about the journal. Start looking, what's the impact factor? This is one thing we do not make mention of. This is one thing we don't make mention of. We can look for impact factor. We can look for the day from time to acceptance and time to decision. We can look for acceptance rates. This is another impact factor. Site score, time to acceptance, time to acceptance rate. So these are the things you need to check. These are the things you need. You can see Elsevier is so much simplified in such a way that you don't need to stress yourself. After you've conducted your research, for instance, let's say undergraduate thesis now. You have written your thesis undergraduate. You now want to publish. You have not written the manuscript. You just pick your abstract from your thesis. You just copy it in your, you copy it in this search box. So it's going to recommend journal that is suitable for your research work based on your abstract. So that is Elsevier. Now the next one is Sage. Now Sage is much more different. It's in the sense that it's asking you to write the title and also asking you to write a selected subject or index that you want. So now I'm going to be using just the title for Sage. You can explore every other thing it is asking. So I'm going to also go back to this place and copy the title of this paper. This is already published. It is already published, but I want to see, I want it to recommend journal that have something in this format where I can publish my paper for me. So now I'm going to just click on find journal. find journal. So this is Sage. Sage is bringing out all the relevant journal that is open as you can see this one. This is open access and Sage part. Open access Sage part. You can see the information, the journal names. But then when you want to see a journal that is subscription, that is when you start seeing S. Because you are Nigerians, for instance, we don't have money. We want to look for a journal that is having subscription option. So you are going to be peculiar about looking for those ones that have this S. So every paper, every journal that have been recommended that is related to this topic that you need, that is subscription, you have to look for the ones that are having S. So now this is another platform, Taylor and Francis. So for Taylor and Francis, it is asking me to paste my abstract, just like Sylvia asked me to do. So I'm going to copy this abstract in this place, and I'm going to bring it to Taylor and Francis. I'm going to copy to Taylor and Francis and review suggested journal. Review suggested journal. So this is going to also recommend journals for me where I can publish. And it's going to show me several of them. So what you need to do now, this one is not showing you whether it is having APC, whether it is subscription or yes, it is showing yes. This is an open access. This is an open access. Open access. Oh, this is open select. Now, when you see open select, it means you can either pay or not pay, just like subscription. Open select. But when you see open access, it means you have to pay. So these are the journals this platform selected for me. And then beyond just selecting journals for you, you have to also go into looking at the scope, like I've discussed in the other part. You need to look at the indexing and abstracts. You need to look at the credibility of the publisher. You need to look at the previous publication. Check if what you want to publish as similar research has been published before. So these are some of the ways. This is Willy, and this is Springer Link. This is Springer Link. So for Springer Link too, you have to go through the same process to check if it's going to recommend journals for you. I think this is where we have to stop today, but I'll have to put this link in the chat box so that we can all have access to it. But then before I finish or before I round up, I'm just going to want to show us the last thing on my slide, which is the highlight of this session. Now, the students with an interest in contributing to STEM, the element to fuel your curiosity should begin before your first degree graduation. That means before you graduate. Now, the essence of all this is because at the end of the day, you want to conduct a research, or when you have conducted a research, you need to have something that is going to show the scientific community that you are not just working in the lab. You have something to show that is going to say, oh, you have experience. You have idea of what you have done so far. So you should come up with something that is going to fuel your curiosity. And when after this curiosity, it doesn't just stop here. You have to also have an interest. And the second part is having an interest is not enough to determine your progress. You have to be involved with practicing the basic research development set skill, like reports writing, thesis writing, and presentation. The other thing I have here is be encouraged to volunteer in an established or growing organization supporting and training the next generation of scientists in a broad field of research area. There are several organizations, there are several platforms in which you can join, volunteer, so that you can also build yourself. And this platform, SciCon, is one of the platforms in which you can join. And the last thing I have here is you need to start working with like-minded people, learning from mentors and building yourself with active scholar. And one of the platforms where you can link up with scholars, you can link up with like-minded mentors is on LinkedIn or Twitter, if you know how to use this platform very well. So these are the highlights of this session. I have some questions here on my page, but I don't know if I'm going to be able to take this, but I'm going to welcome question. I'm going to welcome question from the audience. I'm going to welcome question from the audience. So thank you for listening.
Wow, that's amazing. That's very robust, I must say. Thank you very much, Mr. Chris. It was a wonderful session. a wonderful section. And I think that we actually got more than we bargained for, honestly. This is very robust, I must say. Thank you very much, sir, for taking us through scientific research writing and publication. So thank you very much, sir. So at this point, we are going to entertain question. So if you have any question concerning any part of what Mr. Chris has taught us today, please you can drop it in the chat or just signify so that we can give you the permission to speak.
Let your question come in. This is 4:25 and I've not slept and I need to sleep. So this is
Thank
Sunday
you, sir.
already.
We are
Yeah.
very-
So
we
your
are very
question can
sorry
come
for
in.
disturbing your sleeping time, sir. So if you have
Yeah.
questions, please drop it in the chat, please. Let's allow Mr. Chris to have, even if it is not up to 8 hours recommended sleep, at least. Okay, I think we have a question in the chat. How do we
Okay.
create manuscript properly? Okay, I think
How do we?
curate manuscripts properly. I think this person is
Okay.
talking about it. So,
Okay. If you were following me when I was discussing, I said there is a particular structure in which all manuscript or scientific reports must follow. I said the first thing is the title. Now, if you're having a report, in this sense, a manuscript you want to submit. Now, your manuscript could be any type of scientific report. But in this context, let me assume you are writing an original paper from your undergraduate thesis or master's thesis or PhD thesis, dissertation rather. Now, the first structure you need to know is that your manuscript must have a title for original research. Now, that's what I'm saying. It must have an abstract, it must have introduction, it must have method, it must have discussion and conclusion with references. Now, the reason why you need to have this at the back of your mind is because when you go ahead to check some journal where you want to publish using some of these platforms I've already sent, you are going to notice that some of them is going to ask you to combine some sessions together. For instance, like informatics in medicine and law, I've seen some papers on that platform where they combine result and discussion together into one session. You get into what session you get. So if you are writing a research and it is something you want to have a structured an organized manuscript, you need to know that this is the trend you need to follow. Now, let's say you now check a journal and the journal is now asking you to combine one session, like result and discussion together. That means you will need to just compile these two together, but ordinarily you need to separate it until when, let's say, the platform you want to submit it to is asking you to join it together. You get what I'm saying? So this is a way you need to know how to structure your manuscript. Now, if you are saying curating manuscript, are you saying how to get papers from databases? Or I think that is what I understand by the meaning of this curate manuscript properly. If I don't get you, or if you mean something else. There's another question here. Yesterday's session, the speaker said it is not ethical to publish a paper without a supervisor. Yes, you are an undergraduate, for God's sake. And someone is supervising you. And one thing about Nigerian university, sorry to say this, is that if you have a supervisor, one thing is, the reason why many undergraduates theses are not publishable is because it is not always of high quality. And this supervisor don't have much time to even say, oh, let me see what the student is doing. Now, if you're a student and you don't have idea of what you want to do, and I think I heard yesterday where some people are lamenting that my supervisor is giving to me, it's not what I want to do. Which obviously many people, I also experience it. You get what I'm saying? But that doesn't limit what I wanted to do. Now, you should be able to get an interest or find an interest in whatever your supervisor is doing. Obviously, you are going to be giving a research. But in my own case, I think what my supervisor did was that she just told me, this is the area I'm going to be working on. And I decided what I want to work on myself. She told me this is what she wants me to work on, but I decided the kind of research I want to do. So there are opportunities where you are going to get supervisor that will tell you this is what you should do, and you have no comments to make. So as an undergraduate, you cannot publish without the how will I say it now? Without the consent of your supervisor. You get what I'm saying? So most of the time, undergraduates don't get to publish their work because their supervisor did not give them go ahead. And if you submit your your manuscript without your supervisor consent or without your supervisor saying you should publish it, you know that is a conflict of interest. Because if your supervisor writes to the journal you submit, they can pull down the paper and it's going to affect your career as a young scientist. So that is why you have to come in terms with your supervisor, whoever is going to be training you in your undergraduate, master's, or PhD. These are the people that are going to give you go ahead, tell you, oh, they can even have idea of where they want you to publish. They will tell you, submit in this paper because they have credible knowledge. They have published in those kind of journals before. So there is a lot of things that they are going to save you, stress they are going to save you from, in which their expertise is needed. So if you are going to be publishing a paper, ethically, your supervisor must be the one to give you a go ahead before you can publish. So that statement is correct. Now, another question is, what is the business side of research publication? I think that is not the essence of this class. There is a lot of business class. I know you know many people on platform, like which platform can I mention? You know, I know you know Scholarship Cafe. They are giving people opportunity for scholarship at the same time they are making money. So if you want to know the business side of it, that is another thing for another day. You get of publication. So you can meet me or you can go online, check for platforms like that. So this is not about business side of research publication. Thank you, sir. So following that, okay, another question. Okay.
Lisa, I have a question.
Okay, go ahead.
Okay, for someone that have graduated, okay, thank you very much. For someone that has already graduated from school but was not able to publish the thesis that was done during the undergraduate program, and then you want to pursue a graduate program, but you need to publish a paper. This how can I get to collaborate with people to do research and then publish it?
Okay, that's a very good question. Now,
That's
when
right.
you have a supervisor that is not giving you a go ahead to publish your undergraduate thesis, and you need a publication just to show evidence that you have research experience, you have idea of what you have done as an undergraduate. Now, there's a place of collaboration in which you already said yourself. Now, the way it started out for me was that when I was an undergraduate, I have some friends, colleagues that we work together. So if you see my colleague, you will see me. If you see this person, you will see him. If you see me, you will see him. So when we started out, none of us published our undergraduate thesis because our supervisor did not give us go ahead. But before we graduated, I think we have about maybe 5 or 6 publications because we were working together and we know what we wanted to do at the long run. So you can come up, like you see in my slide, I said, working with like-minded people, working with mentors. For instance, their platform. Let me just mention a platform. I know Helix Biogen, many of their IT students, at the end of the day, they have opportunity to work with their staff to publish paper. That depends on your seriousness or maybe your availability or involvement in their project. And I've seen many undergraduates that have worked there that are having publication even before they reach their final year. So these are avenues, these are ways in which we can get publication. And for instance, my platform, for instance, there are projects we have done in the time past that we work with students, undergraduates, even graduate students. These are places or these are avenues in which you can come up with getting publications. But then before you can be certified as a credible contributor to a paper, that means you must have done something reasonable. You must have added something meaningful to the body of the paper. I hope you are getting what I'm saying. So if you are not adding to a paper and you are expecting that you are going to get opportunity to be included in a paper, that is some of the business side of publication. But I'm not going to go there. That is not what we are here for. So, but then as an undergraduate, you start working with people you know that they are already publishing. So this is where you are going to get opportunity to say, oh, sometimes you can even reach out to your seniors, like let's say master students in your department. Reach out to them, people you know you can talk to, tell them, and you know they are publishing. Let them know you are interested. So if they have any work they are undergoing or they are doing, they can tell you, okay, come and do this. Let's see. If you can do it, they are going to add your name. That is one contribution they have been able to do. And I know several departments. I don't know if I know many people here are going to be Futarians. I know some departments where there are some staffs bring students together to do research, especially departments like biochemistry. You get what I'm saying? So these are avenues where you get to publish paper. These are avenues where you get to work on research that are relevant to your area of interest. And if you are not getting this, go online. Go to Helix Biogen, go to SciCon. I know they also have a research group. Go to them, let them know you want to conduct a research. You have an idea. How can we go about this? So they are going to help you. They can even organize a platform where people are going to come around, start bringing ideas so that you can conduct research. So these are ways you need to go about doing that. So I think there's another question I saw.
Thank you very much. I want to ask
Yeah, thank you. Can we publish articles, not research, without the supervisor, or should article go to blog? We cannot publish your article if it is a work that your supervisor was the one that your professor or your doctor or your department is the one that supervises you. Any work that you have an expert, a senior, a lecturer supervise you, you cannot publish without their consent. Know that and know peace. Should article go to blog? No. If your supervisor is not telling you, publish this article, don't put it on blog. You can write something that can be put on blog, but don't put the content, the data you've generated in your lab on your blog. That is a wrong practice. It's unethical. Like I said, supervisor must give you consent before you do anything. Please, can you type the name of the organization here? Helix Biogen. Yeah, thank you. SciCon is there. There is one platform owned by Dr. Macaulay. They also do research with students. So there is a IITA. I know IITA have some forum where they train students. I know FIRO too does that. I know NIMA does that. And I know NABDA in Abuja does that. So these are where we come into recommending places for students IT, for instance. You spoke about volunteering. What platform would you recommend and how can one go about it? SciCon is a very good platform. You volunteer with them, you get to engage. I don't know if you know, they are coming up with a program very soon, a conference, scientific conference, and they have done one in the past. So these are places where you can volunteer, you can get to know what research is about, you can get to know how to go about research. So this is a good platform too that you can volunteer with. You can volunteer with, Illumina, thank you so much. Wadi is there, Biosphere is there, thank you so much. Everyone is following me. Thank you so much. And I have another question here. Do Frontier and MDPI publish for free? No, we cannot publish for free on MDPI and Frontier. The only thing they do for you is that they give discounts, maybe 20% or 30% discount. And their price is also high, like some Elsevier and Springer Journal. So they only give discounts. They don't publish free. Can undergraduate seminar technical reports be published? No. If your technical report is written like a literature review, comprehensive, you can go about publishing it. But a technical report, you cannot publish it. You can only put it on platform like your ResearchGate so that people will see that you have done something in the area of research writing or scientific writing. So I have, like, for instance, I have my undergraduate, let's see if I can share my screen. I have my undergraduate presentation on my ResearchGate. Let me show you so that you can see what I'm saying. Okay. As far back as my undergraduate. Okay, I want to see, okay. Okay, this is my undergraduate presentation. You can see it's on my ResearchGate. This is my undergraduate presentation. So this is something I put on my platform. You can see it, BTH 2501. So this is on mRNA vaccine technology. So this is something you can put on your platform. Anybody can see it and learn something from it. But then, if it is well written comprehensively, you can submit it as a review. You can see it. So this is my own. You can also put your own on your ResearchGate platform like that. Okay, I didn't say NAFDA. I said NABDA in Abuja. That's a biotechnology center in Abuja. I didn't say NAFDA. NABDA. Any other question? Yeah, NABDA. National Agency of Biotechnology. So I can't really, let me check it. Let me check it. National Biotechnology Development Agency. Can you put it on the ResearchGate without the lecturer go ahead? What do you mean put on the ResearchGate? Your seminar report? Yeah, you can put your report on your seminar, on your ResearchGate platform. Okay, I should show you. Okay. This is a ResearchGate. I want to add something to it. You see add new here, just beside my profile pics. So what do I want to add? Is it a published research? Is it a preprint, conference, presentation, poster, data, order? So this is order, either code, method, negative, raw data, research proposal, thesis. But what I want to submit is a presentation. You can upload, select file from your folder, go ahead, write the name, blah, 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 blah. So that is the way to add it. I hope you can see that. You can go ahead and add it that way. This is it, add new. Thank you.
Alright, I think we missed a question in the chat.
Okay. Which other question?
I'm trying to go back to the question now. Oh. Okay, I had this the question. If my
citation were generated, never
Yeah.
use a citation generated by AI tool. I don't know if you have seen, I saw a research, was it last year? They compared the citation generated using ChatGPT and one other platform. And they discovered that 70% of the citation generated by ChatGPT is fake. From that research, that's a research on its own. So if you are using citation generated by ChatGPT on your own, ChatGPT is not human. It should not do what you are doing. It is only for you to enhance your productivity. It does not make you lazy. So if you are generating a citation using ChatGPT and you are not confirming if it is real or not, you are doing yourself a lot of harm than good. Do you have ResearchGate? The question is, do you have ResearchGate account? If you don't have ResearchGate account, search for it online, register, put your picture, put your information, and start using it. If you don't have it before, this is my name, see my department, see everything about me. You can see other people that I've worked with, places I've worked in, FIRO. So this is ResearchGate. ResearchGate is just like a platform where you keep your research publication. Let's say someone asks you, your publication, where are they? And you cannot write everything in your CV because CV is like a 2-page document. You can just send them the link to your ResearchGate. Another link you can send them is your Google Scholar page. There you are going to see all your papers. So all your papers, every publication you have can be there so they can access it. Is Mendeley Cites AI tool? Mendeley is a referencing manager tool. Mendeley is used by all researchers. And the reason why they use Mendeley is to help you organize your citation. It is not an offense to use AI tool like Mendeley. There is EndNote, there is Zotero. It helps you to organize your citation. You know, when you are writing as an undergraduate, many times you are going to start writing the in-text citation manually. Let's say you now want to make amendments. You start going up and down, start making changes. So with Mendeley, Zotero, EndNotes, referencing managers like this, it helps you to use this writing. It helps you to make writing easy. If it's that we have another opportunity next time, it could be something we want to take. I think we took it in one of our classes that we just ended, that's the thesis writing for undergraduates. So we talked about these tools and we demonstrate how to use these tools. So Mendeley is an AI tool, but it is used just for organizing your writing in terms of in-text citation, footnotes, and bibliography. It could be like a portfolio. Yeah, you are very correct. It's a portfolio site. Like your CV where you compress everything you have done for over 5 years. You can put everything, display everything more on your ResearchGate. Nobody is telling you 2 pages. So that is the essence of having ResearchGate or Google Scholar. But most of the time, this platform is used for saving journal publication or article that are being published.
Wow. Thank you very much, sir, for those great responses, sir. Thank you very much. This has been an all-round learning experience so far. Thank you very much, sir, Mr. Chris. We are so glad to have you. Okay, so if you have any other questions, I think this is the last chance to do that, so that we can release Mr. Chris. Okay,
Thank
I guess. Oh, thank you.
Mine is not particularly a question, but just to show appreciation. I must say the section has really been wonderful and very informative. It's eye-opening. I like the way he took it from the very basic beginning to the in-depth core. It dealt with it mercilessly. But for time, I'm sure he would have gone further than that. Well done,
Of
Mr.
course.
Chris. We are very, very grateful. Thank you very much.
Thank you, sir.
Yeah, thank you very much, Mr. Victor. Thank you very much. So I guess right about now we can release Mr. Chris. So if there's any resources that you would like to share with us, probably links.
Yeah, I'm going to send the documents.
Oh.
And then I think I've sent some of the link for the publishers.
Exactly. Yes, I believe most people should have saved those links by now. It was dropped in the chat, so that you can always make reference to them whenever you need them. So thank you very much, sir. So I will reach out to you to get the documents, sir.
No problem.
All right, thank you very much, sir. Thank you. So okay. All right, I think we've come to the end of the last section in the workshop. So Mr. Chris, I think we can release you now so that you can have.
Okay.
So you can.
Thank you, everyone. Thank you for having me, and I appreciate SciCon. God will continue to bless you guys. I know you are all doing well.
Amen, sir.
and
Thank you.
we keep supporting you. Please try to attend their upcoming program. I don't know if I think it's a festival thing or something.
Yes, it's coming up in September.
Please
Next
join
week.
their program. Even if I'm not attending, my spirit is with you guys.
Yeah, thank you very much, sir. Thank you very much for
Uh,
your constant support, sir.
yeah.
Yeah, thank you, sir. So I will keep in touch, sir.
All right.
Yeah, so guys, this brings us to the end of the workshop. And I want to thank everyone for being an amazing part of this workshop so far. So right now we are going to have a closing remark. Please don't leave yet because we still have some announcements to pass before we are going to disperse here today. So we are going to have a closing remark from the president of Sainkun community, the person of Mr. Anoro Emmanuel. Mr. Emmanuel, please, could you confirm if you are still here with us, sir?
Yeah, hello, good evening.
Good evening, sir. You can hear you, sir.
Hello, can you hear me?
Yes, I can hear from my hand, sir.
Hello?
Hello, sir.
Yeah, I can hear you.
You have the floor, sir.
Yeah, so, like, should I go on?
Yes, sir, please. You can go ahead, sir.
Okay,
Yep.
yeah, so, okay. Yeah, so, firstly, I really want to appreciate everybody for showing up. It's been a very wonderful section so far. Yesterday we started with Mr. Sheung. We talked about the basics of research. He explained a lot of very, very important things. And today we're able to have Mr. Emmanuel and Mr. Christopher. I must say that, yeah, these people are actually people that know what they are doing. And not just know what they are doing, but they have been able to effectively communicate to us the basic ideas that are necessary if we would need to go on as researchers. So, this is part of the thing that Science is trying to do. We're trying to give people the opportunity to groom themselves, people that are interested in research, people that are interested in making a change through science and technology. We're trying to also give them the opportunity to be able to educate themselves rightly as they are working towards that goal. Right. So yeah, I think I just want to appreciate everyone. I want to appreciate Mr. Sharif and his assistants, but and also everyone in the Department of Research and Administration for putting this together. I must say this is like one of the things that we have done, yeah, even in Science that is like very, very like it's a great thing and it just resonates with what we are working towards, right? So I really want to appreciate the convenience of this event. We would not be able to make it here without them. Also the speakers, I want to appreciate everyone. I also want to appreciate the participants, the people that attended the program, right? Your patience is not something that we overlook, right? I really want to appreciate you guys. I hope that we really have learned a lot. I personally have learned a lot. So I want to believe that the rest of us too have learned a lot. So I think I'll close with this that we should not stop here, right? We should make very good use of this information that we have gotten, right? Everything that we have gotten, we should make very good use of it. Um, After now, we'll be sending the documents, files, important links, certifications, all of those things. But the certificate is not what really matters. It's actually how well you have developed yourself and what you can show people, right? That's what matters in today's world. So even as we receive certifications, above that, we should try to make sure that we can apply this knowledge in our various lives, in what we are doing, whether you are still an undergraduate, whether you have already graduated, you are going for your master's, or you're going for a PhD. just application of what we have learned. That's what we really establish what we have been working on so far. So I really want to encourage every one of us that we should make sure that we don't just stop here, but we take this up and we make good use of it. And eventually, by the grace of God, we'll be able to impact lives by research and science. We'll be able to impact lives by building projects and other things. Yeah, thank you very much once again. I'm very grateful, and thank you for having me. Yeah, over to you, Sheriff.
Yeah, thank you very much, Mr. President. We are so glad to have you among us. Throughout the course of the workshop, we are really grateful. And thanks for your word of encouragement as well. Thank you very much, sir. All right, so back to you guys, our MVPs, because you guys are the real MVPs, honestly, because without you, we'll not be able to put this together. And even if we had gone ahead to put this together, it would not have made a lot of success as we have it now without you guys. Thank you very much for being an amazing part of the workshop. And we hope that you found it valuable and you are inspired to apply what you've learned throughout the workshop in everything that you do as young scientists. So we want to encourage you that you keep pushing the boundaries and keep developing your knowledge, because we understand that even despite the fact that we've gone through a lot of things in this workshop, most of the things that we're able to do is just like the fundamental, the basics of every part of scientific research. So this is just to nudge every one of us to continue to develop ourselves. Honestly, because SPSS is, you cannot expect to learn everything about SPSS, for example, in one section, in one single section. It's not possible. It's not done in any part of the world. So it's not possible. Also, you need to like develop what you've learned throughout this workshop, and also extends to the area of publication, because even those people that are in the later phase of their research experience, they are still learning day by day. So as young scientists, we are encouraged to continue to push the boundaries. Let's continue to develop what we have. Let's continue to develop our skills. Watch, just like Mr. Emmanuel Ayeni said to us, that we should continue reading, taking courses, and watching videos, like educational videos. It's going to help us a lot. It's going to go a long way. So thank you very much. So we have some important announcement to pass. So we've come to the end of the workshop, but this is not the end of everything. We will still be in touch with you guys moving forward. And just like it was earlier announced, Science Festival, Science Festival, so that's the word. Science is organizing a Science Festival in September. That's next month. So if you are around Akure, Ondo State, you can join us. You can also follow subsequent announcements regarding that. You can follow that through our LinkedIn page, so that you will be updated. So we are organizing the Science Festival, and it's going to be a big one. Really, it's going to be a big one, where we bring together top-notch scientists, people that are making waves in the sphere of science. So we want to bring them together to like inspire or ignite innovations. So that's the ultimate reason for convening this festival. And it's going to be a whole lot of events. There's going to be a lot of events just to inspire. Okay, so the details are in the chat already. Thank you very much, sir. So it's going to be coming up on the 18th of September at T.I. Francis Hall in the Federal University of Technology, Akure, Ondo State. So if you are very close to Akure, Ondo State, you can join us here in Futa on the 18th of September to witness the biggest festival in the world of science, organized by Science. So that's the biggest gist that we have for you guys. So we are looking forward to your, we look forward to, okay, so I think it's Science. Yes, Science on LinkedIn. Just type Science, is going to bring it. Yeah, so that's the name on LinkedIn. So you can always follow us. You can always keep a tab on our event and subsequent workshops too. So the link to the attendance attendance has been dropped in the chat. So, and I want to believe that every one of us has filled the attendance, because that is what we are going to be using to determine those who will be eligible to get a certificate from the workshop. So make sure you fill in correctly, because your name and the email that you provide is going to be what you're going to use to send in the certificate. So everybody's going to get a certificate. Sorry, those that are eligible, those that are qualified to get certificates, we get them. And also the resources. I think that we are going to be having the slides from Mr. Sheon's session, and also the slides from Mr. Emmanuel's sessions, and also the link to the attendance. It will be dropped again now. So there you go. Please make sure you fill the attendance before you leave, please, before we are going to leave here today, please. It's very important. So we have the slides from Mr. Emmanuel's session as well, and also the what's it called now? The setup for SPS, was it SPSS or R Studio? Yeah, I guess. So we are going to put everything together and forward it. And also the slides, I think he has dropped it already. Mr. Chris, he has dropped his slides already. And also any other resource that you will most likely want to share with you guys. So we're going to put them together and share with you alongside your certificates for those that will be qualified to get certificates. So we are considering that we are going to consider those that are able to attend just 1 day out of the 2 days for the workshop. So, but you have to show us that you really were present at on that 1 day of the workshop, so that we can be convinced that you've gained something, and you're really present in the workshop. So thank you very much once again. So please make sure that you have filled the attendance. It's very important, please. It's very important. Make sure you fill the attendance by let's say the next 3 working days. That is by Wednesday next week. Every resources and the certificate should get to those that are qualified for it by God's grace. By God's grace. So be expecting the certificate and every other resources that I want to share with you by then, by Wednesday latest. Yeah, so I think at this point, we have come to the end of this amazing workshop. And I want to appreciate you guys again for being a part of this. We really appreciate you, and we hope to continue to have further engagements with you guys in future, moving forward. So don't forget, Synchron Science Festival is coming up on the 18th of September. So we'll be looking forward to meeting you guys by then, for those of you that will be able to witness it. So thank you very much. So please, once again, fill in the attendance. And at this point, if you have filled the attendance, you may take your leave. Yeah, see you guys later. Thank you very much. So we are going to continue our conversation on the WhatsApp group. Thank you very much.